particularly, particularly on a Sunday morning at 9 a.m. So I am Indrajit Bhattacharya, and I would like to welcome you all to the Data Science in India workshop as part of IKDD 2024. So this event is organized by IKDD, which is the India chapter of ACM IKDD. Before getting into the workshop, I would like to take this opportunity to tell you very briefly about IKDD. Yeah, I know. You came here to listen to Mitesh and all the other fantastic panelists and speakers we have lined up for you, but this is the small price that you pay, for getting to listen to them. You have to bear with me for a couple of minutes. So IKDD is the professional chapter of IKDD in India. It was established as an ACM India chapter in 2011. And our mission, very broadly, is to help strengthen the data science ecosystem in India. So a new committee took over in May of 2024. So aside from the office bearers, myself, Rajana, and Raj, we have an extended core committee to set up and drive an ambitious agenda. And as you can see, we have great quality as well as diversity in the core committee. And I would hasten to add that beyond the core committee, we are supported by many enthusiastic volunteers for our many activities. So a heartfelt thank you to all of you. So our flagship annual event is the CODS COMAD conference. So this is the premier data science, or rather data conference in India, bringing together both data science and databases. So the CODS and COMAD conferences, these merged in 2018 to become the vibrant conference of today. So this is where the data science and database communities in India get together every year. So the conference itself is marked by stellar keynote talks, occasionally with a Turing Award winner thrown in. We have research, applied, and demo tracks. We have topical tutorials. Since 2021, we have a workshop for promoting diversity and inclusion in the data science and database communities in India. The Young Researchers Symposium, including a live in-person PhD clinic, has evolved as a fantastic forum for giving feedback to young researchers and early career researchers. And we give away lots of student travel grants to enable students from across the country to attend this event. So the 2024 edition, or rather the December 2024 edition, is going to be in IIT Jodhpur between December 18th and 21st. On the right, you can see some of the deadlines that are still coming up. And we certainly hope to see many of you joining us there. So the PhD programs in our various academic institutes are really the cradles of our future researchers. And to recognize and incentivize outstanding research in data science by PhD scholars in Indian institutes, we started the Best Doctoral Dissertation Award in Data Science in 2022, actually. Every time I try to say this name out loud now, I promise you this was not our intent, but it sounds like a bit of a tongue twister. But unfortunately, the name has stuck. This has already become a coveted award and attracts applications from top institutes across the country. These were the winners from, and very richly deserved winners from the previous edition in 2023. And note that the deadline for 2024 is at the end of August. So we strongly believe that India has enough talent that is crying out for quality research mentorship. And the Uplink internship program, it was started in 2022, so is meant for deserving students who are aspiring to do research in data science, but do not have access to a world-class research ecosystem. So this program aims to pair up such students with fantastic academic research mentors from the top institutes in India. And what you see on the right is the highlight of our program over the last 2 years. So this work by Ujan Deb, mentored by Professor Preethi Jyothi from IIT Bombay, was accepted at ACL 2023. We had, the presentations for this year's interns yesterday. We have the second round next week. And I'm really looking forward, we are all really looking forward to many such highlights in this year and the years to come. And we have seen fantastic response for this program over the last 3 years, as you can see from some of these numbers. So the first step to improvement, you could say, is measurement. We all know that quality research output from India around data science is growing, but can we quantify it? So the Premier Papers repository is an effort towards this direction. So the aim of this repository is to be a one-stop shop for all core A-star papers published from India in all data science conferences. So as you can imagine, this is ambitious and somewhat complicated to fully automate. You can probably imagine why. So right now, this works with a mix of crowdsourcing and automation. We have been able to make some progress towards this goal, but a lot more needs to be done. So if you can help us by maybe helping spreading the word, asking your friends and maybe yourself and your team to submit your papers on our online, using our online form, that will certainly be very helpful. We also organize data science meetups from time to time to enable meaningful conversations for the data science community in India. The latest event happened in July. And all of these events, like today's event, are free to attend and open for everyone to join. So we look forward to having some of you and more of you join us in our future data science meetups. So finally, let me tell you briefly about the Data Science in India workshop, which you have gathered to attend today. So this started as a part of the ACMC KDD annual conference in 2015, which actually means that today we are here to celebrate the 10th birthday of DSI. So thanks to all of you for joining us today. And thanks again for making it successful. So the program, today's event, or rather the event in general, has two overarching goals. One is to showcase, great research around data science, not just research, various other activities, including institution building, and other activities which are happening in India around data science. And the other is to help build bridges and enable conversations, not only between various groups working on data science in India, but bridges from outside India to India. And we have put together a great program today. But before I get into that, I just consider this to be an appeal. If you like what we do, please connect with us over the various channels that we have listed here. But more importantly, this is not something that a couple of people can do, right? So if you like what we do and you would like to join us, we are always looking for enthusiastic volunteers. In fact, we have some networking roundtables at the end of today's program. And one of the roundtables is about working and collaborating with IKDD. So I'll hope to see some of you join us there. Okay, so finally, this is what all of you are here for today. We have put together a great program for all of you to enjoy, and hope you get something to take away from it. But to tell you more about it, let me just hand over to Advait. Over to you, Advait. Thank you.
Hi, Indrajit. Thank you. I am Advait from IIT Kharagpur. So it is my pleasure to you to introduce the program. Like we just had the welcome address from Indrajit, who is the president of ACM IKDD. Now we are going to have the first item, which is the keynote talk by Professor Mitesh Khapra. He is going to tell us about transforming Indian language technology ecosystem. After this, this event will be for 1 hour, including question and answer session. So if you have any question and answer, please feel free to type it in the chat box. And at the end of the talk by Mitesh, we will curate the questions and read out, and Mitesh can answer them. And at 10:15, we will have a track which we are introducing for the first time in PSI. In this case, we will be focusing on the emerging applications of data science in India. That is the applications which are somewhat different from computer vision and natural language processing and so on. So we will have four short talks by different researchers who are working in these domains, including Srinivasan and Shivkumar from Microsoft Research, Tavpritesh Sethi from IIIT Delhi, Tirthankar from TCS Research, and Varun Gulshan from Google Research. We'll have these four short talks followed by another Q&A session for all of these talks combined together. So once again, when the talks are going on, you are free to type in your questions in the chat box. And if there is at the end, we'll curate all of them together. At 11:30, we will have a panel discussion. The aim of this panel discussion will be to discuss the career opportunities related to data science in different sectors of India, the government, industry, academia, the social sector, and so on. And we have our 5 panelists who represent these different sectors. So we will have panel discussions. At 12:30, we will have this breakout session where there will be 4 different breakout rooms, each representing a theme. These themes include the careers in data science, the various innovative applications of data science and AI, multilingual and multimodal generative AI in India, and finally, how you can work with IKDD. So, we will have a separate Zoom link for this session, and I believe Raj has already posted it on the chat box. So, as we start this program, I'd like to specially thank Raj, who has been in charge of publicity and communications for this event, and Abhinaya, who has been the chair of our web team. So with that, we would like to start the next event as it's 9:15. This is going to be a keynote talk by Professor Mitesh Khapra. So it is my pleasure to introduce to you Professor Mitesh Khapra. He is currently an associate professor in the Department of Computer Science and Engineering in IIT Madras. Professor Mitesh heads the AI for Bharat Research Lab in IIT Madras, which focuses on building datasets, tools, models, and applications for Indian languages. His research work has been published in several top conferences and journals, including ESEL, ACL, NeurIPS, TALIP, EMNLP, ESEL, IIII, etc. He has served as area chair and senior PC member in top conferences like ICLR and IIII. Prior to joining IIT Madras, he was a researcher at IBM Research India, where he worked on problems related to statistical machine translation, cross-language learning, multimodal learning, argument learning, and deep learning. And prior to joining IBM, he had completed his PhD and MTech from IIT Bombay. His PhD thesis dealt with the important problem of using resources for multilingual computation. And during his PhD, he was a recipient of several awards, including the IBM PhD Research Fellowship and Microsoft Rising Star Fellowship. As a faculty member, Professor Mitesh has also received the Google Faculty Research Award, the IIT Madras Young Faculty Recognition Award, Professor Yagganarayan Award for Excellence in Research and Teaching, and the Srimati Marti Annapurna Gurunath Award for Excellence in Teaching in 2022. Professor Mitesh, it is my pleasure to now open the stage for you to share your deep thoughts about the language technology in India. Over to you, Professor Mitesh.
Thanks, Advay, and thanks, IKD team, for inviting me here. It's a pleasure to come here and talk about some of the work that we and others in the ecosystem have been doing over the past few years in the interest of improving AI technology for Indian languages. Right. So before I sort of get into the talk, just quick check whether I'm audible, whether the slides are clearly visible, and then I can start.
You're good, Mitesh.
Yeah, so let's begin. As was mentioned, I lead this research group at IIT Madras called AI for Bharat. And over the past few years, we have been on a journey to accelerate the development of AI technology for Indian languages. And very simply stated, our mission is that we want parity in AI technology for Indian languages with English, right? So whatever you take for granted today for English, as far as AI models are concerned, the same thing should be taken for granted for Indian languages. That's what our mission is. And we want to do this in the open source by contributing data sets, models, tools, and applications, which can help the ecosystem in building applications and solutions which require Indian language technology. So now the first question is, why do we focus on language technology? Why not anything else, right? So here's one sort of introductory cartoon to help you understand. Of course, most of us probably do understand why it is important. But here's a scenario where you have a farmer in Tamil Nadu who wants to converse with a wholesale dealer in Maharashtra, right? And of course, they speak different languages. And this communication should be possible. But turns out, if you look at the map on the right-hand side of the screen, then if you were to randomly take any two Indians from any part of the country, just randomly take from the entire population of country, take two Indians, then there's only a 36% chance that they will be able to talk to each other because of the language barrier, right? So in India, speech and language technologies are absolutely essential, right? It's a necessity as opposed to a luxury to bridge the language divide that exists in India and to enable these kind of conversations between different people belonging to different parts of the country. And this is not very imaginary, or this is not a situation that we've just cooked up for the sake of motivating the problem, but this is very routine, right? We have people migrating for jobs where this problem is very routine, where someone from a different part of the country comes to a new part of the country, does not understand the local language, has to communicate both ways, right? So that's a very real problem for us. And hence we wanted to focus on language technology to bridge this. While we started with this, the world evolved, and today no one wants to talk to other humans, but people want to talk to AI models, like ChatGPT being one of those, right? And even in this case, the language technology bridge is very, very essential to ensure that our people from diverse backgrounds, be it from remote parts of the country, can access the developments that are happening at the forefront of AI in their regional language, right? And the choice should not be between going digital and staying original. Right? So you should be able to have access to all digital services, all the good products which are being built on top of the latest AI technology while you're interacting with them in your regional language, right? And this is, again, very essential that speech and language technology acts as a bridge in these cases. That's the reason why we focus on language technology. Now, the question is that if we wanted to focus on this, why did we have to do something about it? Right? Was it not already a solved problem? And this is, the status is 2021 when we started, right? And I've looked at 4 important pillars here. Of course, LLMs were not as big as that time as they are today, both sort of in terms of size as well as metaphorically, right? So, but at that time, these foundational technologies were important, which is machine translation, basic language understanding, making sentiment analysis work for Indian languages, basic information extraction work for Indian languages, speech recognition, speech synthesis, right? And across the board, right, what you see in the charts below is the bar for Indian languages, right? The performance for Indian languages was way behind that for English and some of the other more resourced or well-resourced languages, right? And just a point on the third chart here, don't get too excited about that. That chart is not showing accuracy, it's showing error rates. The higher the bar, the poorer the performance, right? So there again, that's for speech recognition. And again, there we see that the performance for Indian languages was quite poor, right? So we were really lagging behind, right? Now the question is, why was this the case? Right? Is it something inherently with the languages that was causing this? Why was it the case that languages like English, Chinese, Japanese, etc. were racing ahead in terms of where their AI technology was, whereas Indian languages were lagging behind? And of course, no points for guessing what the reason was. It's a very straightforward answer. A lack of data is the root cause of all sorts, right? We did not have enough data to build models for Indian languages, right? And that's the reason the Indian language technology was where it was. Now here, of course, there's more nuance to this, and I would like to spend a minute on discussing that. It's not that we were not creating resource before 2020. Right? Of course, there's a lot of effort happened in the past, which has led to data sets being created. It's just that the process of creating data is so expensive and time consuming that we were not at a level where the deep learning models, we were not at a level where we could have enough data which could be consumed by deep learning models. So deep learning models are extremely hungry, but after being fed, they also perform very well, right? So that hunger is sort of well deserved in some sense, but we did not have enough fuel to feed these models. Now the question is why? What does it take to create data? What is the big deal? If you want data, just create it, right? So let's take one example, which is of machine translation, right? Now, general wisdom around that time was that if you want to build a good machine translation system between a pair of languages, and I mean good in a subjective sense here, but just to elaborate a bit on that is that if you want a machine translation system such that if you have a human translator, then the human translator would prefer to work with the output of the machine and correct it rather than starting from scratch. Right? That's what I mean by a good machine translation system. Then you would need order 1 million sentence pairs for that language. Right? Now, we have 22 scheduled languages. Of course, I'll not get into the hundreds of other languages that we have, but just speaking about the 22 scheduled languages that we have. And if you were to create this data, 1 million pairs, sentence pairs, each sentence on average having 15 words and the cost of translation being 3 rupees per word, right? Which seems very high, but that's what the reality is. These rates are not very different even today, right? And this would require a huge investment. Not just investment, the process of manually creating data is of course very tedious. It's not possible to have 1,000 translators who can translate between English and Dogri or English and Bodo or English and Manipuri and sort of get this done in a few months or weeks. It'll take a lot of time to get there, right? So that's one problem that we have to deal with. How do we solve this problem? Not just for machine translation, let's take another example, right? So the famous, very popular speech recognition dataset for English is the Libri speech dataset, which has around 960 hours of data. Of course, now there are much larger datasets on which people train and typically mine from the web and so on. But this was one of the most popular datasets, which is still used in most works that we come across for English, right? So taking that as the benchmark, which is 96 hours, so roughly 1,000 hours is what you need for a decent speech recognition system to give you somewhere around, say, 15% to 20% WER, right? Which is okay for many use cases. Still not perfect, but at least you could start with that and then probably specialize for your domains. So that again is quite costly because you can't just take data from the web. The obvious solution would be to just take YouTube, but then you don't have transcripts for Indian languages. Also, you want real usage data from the ground, right? How do people speak in noisy environments and so on? And collecting this kind of data is also quite expensive, right? So what do we do then? So this is the recipe that we chose, which was sort of well tested for English and some of the other languages by the big deep tech industry, right? And what is this recipe? Very simply stated, you don't wait for data to be collected, right? Because that's going to take both time and money investment. But there's a large amount of noisy data available on the web. And today, deep learning models are at a stage where they can consume noise better than what our previous generation models were. Right? So they can sort of work with a mix of noisy and clean data. And this large amount of noisy data is abundant on the web. Right? I'll elaborate a bit more when I talk about machine translation and how we went about collecting data for machine translation. Right? And then supplement it with a small amount of manually created data. At no point I would advocate that manual data is not important. It's as important as creating this quick data from the web, right? You need a small amount of manually created data, if not for anything else, at least for benchmarking or for fine-tuning the models, right? You have trained them on a large amount of noisy data. Now, can you do a bit of course correction with a small amount of manual data? Right? And then exploit the language similarity between Indian languages so that even if you get lesser amount of data for something like a Maithili language, then it might be able to benefit from some transfer from Hindi. Similarly, Konkani might be able to benefit from some transfer from Marathi and so on, right? So just focus on building large-scale multilingual models where this transfer sort of happens both implicitly and it can also be made explicit, right? So this is the recipe that we chose because we felt that if we have an engineering heavy approach where we are relying on mining large amounts of data, then we could quickly sort of leapfrog over this problem of collecting manual data at scale, right? So that's where we started. Now, this approach is sort of a bit heavy on engineering, right? So what do I mean by that? You need to create very robust data pipelines because on the web, data is quite noisy, right? And over the past few years, enough has been said and written about this in terms of building large language models, where people have shown that investing in creating very robust data pipelines for ensuring that all the data that you crawl from the web is filtered to keep really high quality data, right? And one example of this is the refined web paper, right, where they have a pipeline where only at the end around 11 to 12% of the total data that they had passes through the pipeline, right? And you rely on the volume, even that 11 to 10% was 5 trillion tokens, right? So this has been a theme at AI for Bharat in what we do. We build these pipelines, but make sure that we have very good filters to throw away as much noise as possible. Not that noise still does not creep in, it does, but we focus on doing whatever best can be done with the tools of that time, right? So we have built multiple such pipelines. One of the pipelines, Sethi, which was recently published at ACL, is used to crawl data for Indian languages, right? So we have collected a lot of URLs which have been vetted by humans, right? So that's one more thing that we do here. We sort of complement or supplement the automatic machine crawling effort with a lot of human verification effort. So we make sure that every URL that we crawl is vetted by a human, because in Indian languages, a lot of content is machine translated, right? So, and also sometimes the website says this is Punjabi website or it is like a Hindi website, but a large part of the content may actually not be Hindi, right? And it might, if it is even in the regional language, it might be translated. So we get the URLs vetted by humans. Similarly, we have a pipeline for taking YouTube data and sort of transcribing it in a pseudo labeling approach, where we have some initial base model and we have built this framework called Pratinidhi, where you take 2 or 3 or more base models and ask them all to label unlabeled data coming in from YouTube and other sources. And only if all the models agree on the labels, then we sort of add it to the training data, right? And this again gives us the importance of, or the benefit of doing this is that on YouTube, we have a lot of audio data. It's just that it's not transcribed, but the audio data is very valuable, very diverse. You have audios on people talking about their vacation blogs, or they are talking about recipes and other Indian context and so on, right? Which is very diverse. And it's hard to sort of go out and collect such data. But you could get it for free from YouTube, and it's just that you have to be careful about how you label it. Right? Then the other pipeline that we have built is the Saman pipeline, which is for crawling parallel data from the web. Right? This is one of our initial flagship works, which sort of is very widely used even today. Our models on translation are used by many people, and we get very good feedback for that. And a lot of the data that goes into training the translation model has been mined from the web. Mind you, it's very noisy data, but I think the strength of the models today is they're able to consume this noisy data. And of course, when fine-tuned with a small amount of, relatively smaller amount of manually created data, the model works quite well, right? So we have invested a lot in creating these pipelines, and all of this is open source for others to use. Now, coming to the manual data collection part, right? And here we have had a large-scale effort of collecting data for Indian languages. This is funded by the ambitious Bhashini project under MIT, where the goal is to collect 1 lakh parallel sentences between English and 22 languages, and around 500 to 1,000 hours for each of the 22 languages from the ground, right? So we have a team of volunteers, coordinators across the country. We are collecting data from 500 plus districts out of the 700 districts in India, where our team goes to a district and sort of mobilizes around 150 participants, balanced across demographics like gender, age, education backgrounds, and so on. And then we start collecting voice samples from them, or using a well-curated set of questions across domains and topics of interest, right? So we'll ask them, oh, what is the topic of interest? Is it politics, sports, entertainment, music, rock climbing, and whatnot. We have a huge list of some 60 such topics. And then we have curated questions for each of these topics, and then we ask them to talk. Right? We also ask them to talk about use cases. Right? Imagine you have ordered food from Swiggy, and now you want to redirect the person to a different address. Imagine you're making that call, and what would you talk on the call, right? And they just start speaking extempore about, or sort of enacting that scenario, right? Now, the reason I'm saying all this is that for you to realize that doing this at scale, I'm talking about 500 plus districts out of the 700 districts in the country, a distributed team of coordinators, and once the data comes in, there's a distributed team of transcribers who are on our payrolls, but are spread across the country. And I cannot expect a Dogri transcriber to come and work out of our office in Chennai, right? So they work from home wherever they are. And managing workflows across such a distributed team is indeed challenging. And it's not just one task, it's a series of tasks. That is data collection from the ground. Then there is transcription. Within transcription, you have maker, checker, and sometimes super checker. Then we have translation. Within translation, you first have the verification of source sentences, then translation, then maker, checker, and so on, right? So for all of this, we have built a tool ground up from scratch, and hence the name Shunya, for allowing annotations and managing workflows for Indian languages. And this tool is again open source, and I'm very proud to say that we are now partnering with AI Singapore, where they have a very similar effort. We focus on 22 languages. They focus on 11 languages, but unlike us, those 11 languages are not within a single country. They are spread across countries, so Philippines, Thai, Malaysia, and so on, right? And they want to do a very similar data collection of capturing voice samples from the ground. Of course, a lot of it is also motivated by LLM, so there are prompts and responses being collected and so on. And the Shunya and Karya tools that we have built for data collection. Karya, our version of Karya is of course built on top of the open source Microsoft version of Karya. And both these are open sourced, and now they're being used by, or at least piloted by AI Singapore, and very, very excited about it to see if we can help collect data for other languages also. And once we have this data collection data at scale, as we said, we focus on having multilingual models, which are a sort of very large scale, right? Now, of course, the large scale definition has changed. Anything less than 100 billion parameters is perhaps not large scale, but at least in our scheme of things, even like a 2 billion parameter model when we started off was fairly large scale. Right? And we had to make sure that we efficiently use the compute that we have. I'll just take a pause here again to check, because I just see that the power has gone out. Am I still audible and everything okay?
Everything is perfect, Mitesh. Please go ahead.
Oh, yeah. So that's what I mean by heavy on engineering and sort of building things ground up in open source so that everyone can use, right? Moving forward, so sorry. Yeah. So this is the recipe that we have. So what have we cooked so far? As I said, one of our flagship works is on machine translation, where we have mined 232 million parallel sentences from web sources. And then with the help of our in-house team, we have created around, now actually this number has become 1.7 million training samples manually, summed up across all the 22 languages, and a benchmark which is grounded in Indian context, right? So what do I mean by that? The most popular benchmark today for machine translation is the Fluor's benchmark, which was released by Meta. But there, the source sentences are all grounded in the Western context, right? So you'll have a sentence about Trump, and then it has been translated to multiple languages and so on, right? But we also wanted sentences which are coming from the Indian context. For example, there should be an English sentence in Bharatnatyam, and then we want it to be translated to 22 languages and see whether the models are able to do it, right? There should be a sentence on Battle of Panipat, which is again very Indian named entities, Indian context, and so on. And are the models doing a good job, right? So we sort of created a benchmark from scratch, which is multi-domain and also has a bit of formal as well as informal translation. So some of these are conversational sentences where you would be talking to a friend asking about how do I get to Bannerghatta Zoo and so on. And then we train a large-scale multilingual model. And this slide sort of summarizes, right, whether we have been able to move the needle on translation with the help of the recipe that I just spoke about, right? And I'll just take a few minutes to explain this chart. So the x-axis, you have the timeline, right, starting from 2020 up to 2023. On the y-axis, you have a measure for the performance of machine translation, right? The higher, the better. And of course, what is a good measure for machine translation is itself an area of research, but let's take one of those measures and stick to it, which works well for Indian languages as sort of demonstrated by multiple research groups and so on, right? So on the y-axis, again, you have a measure for the accuracy of the machine translation, the higher the better. So in 2020, Meta had released a model, which was a multilingual machine translation model, which supported 100 languages. Right? Any language that you see below the 0% axis is a language that was not supported by that particular model. Right? So as you can see, there were many Indian languages which were not supported. Amongst the languages that were supported, there were many which fell below the 20% line, right? Which is like not really a great translation system. And the others were spread from 20 to up to 50. Then in 2021, we released our first INDIC-Trans model. As you can see, again, many languages were not supported. But for the ones that were supported, we were able to sort of push the bar a bit up, and the performance on all these languages was better than what was there in the M2M model by Meta. Then in 2022, Meta released its next model, which was No Language Left Behind. And this supported 40,000 translation directions, right? Pairs of languages. And they again moved the needle, but there were many languages, a few languages maybe, which were still not supported. Right? And in 2023, then we released the next version of our model. And as you can see, everything has moved up now, and there is no Indian language which is not supported, right? And let me see if I have this on slide. So the 60% or the somewhere between 50 to 60%, right? In my opinion, is the line where machine translation systems become usable in practical scenarios. What do I mean by that? If you look at the applications of machine translation, right, there are two broad categories. Right? One is something like a literary translation, where I have a news article released by, say, the Press Bureau of India, and I want to translate it to 20 languages. Accuracy is very important here. Or I have a Supreme Court judgment which needs to be translated to multiple languages. Again, it has to be very accurate, right? In these cases, I don't think the technology is there today where you can just automatically translate and be done, right? But what the goal should be in such use cases is that if I have a human translator who translates from scratch, then would the human be okay in saying that, no, first give me your machine translation output. I would rather edit it, and that would get the job done faster as opposed to me translating from scratch. As I was saying 4 years, 5 years back, for most Indian languages, machine translation was at a level where our in-house annotators used to always say that, hey, please don't show me that output. I would rather translate from scratch, right? And this 50 to 60% sort of range is the range at which that starts changing. Translators then say that, okay, I see that there are errors. It's not perfect, but I would rather work with this instead of translating from scratch, right? That's for the literary translation work. The other set of applications where machine translation is used, and increasingly in the LLM world, is for information, conveying information or the need of the user. Right? So I'm talking to a bot, I'm talking in my regional language. The LLM running behind the bot is probably better off in answering in English because it has been trained on a lot of English data. So I want to do this translation for the LLM to understand. Right? Or just imagine that you are in a shop where you want to buy, say, 5 kg potatoes, 7 kg tomatoes and whatnot. And in this case, you're not really looking to translate it with perfect syntax, perfect semantics. As long as the information is conveyed, you're good. And at this range, again, the 50% to 60% mark, you could deploy these in situations where the goal is only to convey information and not really worry too much about whether it was the best form sentence in Tamil or the best form sentence in Hindi, as long as the information is being conveyed. Right? So as you can see, many languages have reached that level. Of course, there are a few which are still lacking behind. And now as we speak in 2024, right now we are in the process of building the next version of our model, which will be INDIC-Trans 3. And we hope to release in a couple of months. And we hope that these bubbles again continue to move up, right? On the right-hand side, the chart that you see is the comparison with commercial as well as open source models from deep tech, Azure, Google, Meta. And across the board, you can see that our models are comparable or are better than the commercial models or the models coming out of deep tech, right? Of course, one disclaimer here, these numbers are averaged across languages. There are 22 languages and across benchmarks. Right? There is our benchmark, there's the Fluence benchmark, there might be some other small benchmarks which we would have evaluated around. So there are many numbers which have been averaged here and put into this chart. I'm sure that on some of those benchmarks for some of those languages, we may be behind and so on. But overall, objectively speaking, I think now we are at a stage where in the open source, we can afford to have models which are comparable with what we get in the commercial world. Right? And we hope that this situation keeps improving. So that's, let me move on now, right? So now, okay, we have done enough for machine translation, or maybe not enough yet, but we have made some start for machine translation. Is this recipe reusable? Like, can we apply it to other areas of language technology? And the answer is yes. We have also done this for speech recognition, where again, the same idea of mining noisy data from the web. What we did here is we took news on All India Radio broadcast. So the government of India, All India Radio, broadcasts 10-minute news, news every 3 times a day in 40+ languages, right? And since this is news content, the corresponding transcript is also written because the news reader is reading from a transcript, right? It's a very high fidelity application. So we were able to crawl this data from the web and then automatically align the audio, because this is a long audio, right? This is a 10-minute audio which we get, and like a huge PDF that we get which has the transcripts. Sometimes there are some markers for advertisement or some other interview snippets and so on. So it needs to be aligned so that the audio is exactly matching the transcript from the document. And this is very similar to mining parallel data. It's just that here the parallelness is between 2 different modalities, right? And we're able to mine a lot of data. This is one way of creating synthetic data. Now there are other ways of creating synthetic data today, which I'm not going to. And using all of this, we plan to collect around 50K hours of synthetic data for Indian languages, of which around 10,000 hours we have already done. We have also been mining a lot of raw audio, because when we started, pre-training was a big thing. I think Wave to Vec had just come out that time, and it was pre-trained on a large amount of data, and on multiple benchmarks for English, it was shown to perform well. So we wanted to repeat that for Indian languages. We did actually. We built Wave to Vec using raw audio data as pre-training. But now there has been different shifts in the technology, and at least I'm not fully convinced that at least in the audio case, the raw audio pre-training is helping as much as it was 3 to 4 years back. Because this would be a area of discussion or debate itself, but I'm just sharing my views on that. Right? So we may still collect more data from the point of view of pseudo-labeling so that we can create more synthetic data. In parallel, I already spoke about the effort where we are collecting data from multiple districts around the country. Our goal is to collect 20,000 hours summed up across the 22 languages. We have already collected around 13,000 hours of data, of which around 6,000 hours has already been labeled. Right? So we are on that journey, and we keep releasing data sets as at different, at regular milestones, right? Whenever we think we have enough for it to show up in the model performance and so on. And we have trained multiple models, which are again, I believe, widely used by academia and industry. Right? So this recipe is indeed reusable, and we have done this for transliteration, we have done this for translation, we've done this for speech recognition, and this year we are focusing on speech synthesis and optical character recognition. Our goal is hopefully by March 2025 for all these foundational technologies, right? The word foundational is used quite often. I'm using it in a very different context. I'm not saying foundational models, but foundational technologies, which are important to drive progress in AI for Indian languages. Hopefully, we'll have models for all the 22 languages by March 2025. Okay, so we have been cooking a lot of stuff, but the proof of the pudding is in eating it. So are these models actually being used somewhere? Is there any benefit of them and so on? Fortunately, yes. We work with several partners, one of them being HTEP Foundation, Bhashini and Mighty being another. Through this, we get access to people who have real problems on the ground, and we also get access to people who can help us connect and sort of make sure that we only are on the technical side of things and don't really get into the day-to-day of solving the problem, but just provide the technical solution that is required to solve the problem. Right? And these are sort of a snapshot of the few places where our models are being used. So we work with the Tamil Nadu government through HTEP Foundation, where the goal is to improve reading skills. We have built a very simple application where the student sort of logs into a computer at the school and they see a sentence which is in Tamil and they read it. As they are reading it, our automatic speech recognition system for Tamil runs in the background, and it just tries to identify whether what was spoken matches the word that was shown on the screen. If not, it marks it as an error. And now once you have this, you can imagine all sorts of analytics and improvements on top of that. Now you realize that this student is confusing between per and ber. So maybe let me show the student more words involving the letters per and ber, right? And that is sort of the usual personalized improvements that you can get once you have such a system. Through Bhashini, we work with NPCI to enable digital voice payments. This was launched last year. We also work closely with the Supreme Court. So since the inception of Supreme Court, 35,000 releasable judgments have been put out, right? And the Honorable CJI has come up with this very remarkable goal of translating these documents to as many Indian languages, starting with 12 to begin with, right? And as of now, using our translation systems, 27,000 documents have been translated. But as I said, this is a high fidelity application where you cannot just do automatic translation. So with the help of Akestep, we have built a tool around this, which is called Anuvad. That's a human in the loop approach where the machine generates an initial translation, but the Supreme Court has engaged retired judges who are experts in this field and of course are also experts in their native language, who then verify and correct the translation, right? And using this, 27,000 judgments have been translated from English to Hindi. And overall, I believe across 12 languages, summed up across 12 languages, close to 1 lakh judgments have been translated, right? That is the sum of across all languages, not 1 lakh individual documents into the 10 languages. Also, some applications in PM Kisan where people are interacting through voice. In the background, there's a LLM running, but we sort of take care of the voice recognition part. And I believe I've been told that a lot of calls are being made on this, and some of the farmer queries are getting resolved. So it's for us, it has always been important that whatever we build sort of has impact on the ground, and that's why we put it out in the open source. That's why we engage with partners who can use it and try to use that feedback to also improve our models where possible. Now, zooming out a bit, right? I spoke about different verticals. Now let's zoom out and see what we do at a high level. As I said, we build tools for data collection. We collect a lot of data, either through synthetic means or mining and so on, or actually on-field in-house data collection, and use it to build models. We're curating some of the largest data sets for Indian languages, training state-of-the-art models, and also building apps or solutions using these models with the help of partners, right? And making sure that they get used on the ground. And these are the different verticals that we have been interested in. And recently, one more vertical added this year, which is on optical character recognition, right? Now, the middle part here is on language understanding and language generation, which now popularly is a part of large language models, right? So let me take a pause here and as I move sort of segue into the next part and see if we are doing good on time and any other issues that I should be mindful.
I think everything is like you're in order.
Okay, so let's go ahead. Now, what are the experiences we have had in working on these foundational technologies? So when we started off in 2021, as I said, LLMs were not that big. They were not on our radar. We had built the Gen 0 LLMs, which was Indic, BERT, and so on, but they were nowhere close to, in capability close to what we see today in LLMs, right? And now, of course, there's a lot of interest in building Indic LLMs. So the question is, can we take the experiences that we have had in other foundational technologies to Indic LLMs? But before I answer that question, I think I would like to ask, what do we mean by Indic LLMs, right? So what does the word Indic LLM mean? And to me, it could mean 3 different things, right? So LLMs for Indian use cases, right? So when I say Indic LLMs, maybe I mean LLMs for Indian use cases. or it could mean LLMs of Indian language, right? So these are models of languages. So it's a language model of English, it's a language model of Hindi. So is it a large language model of Indian languages? Or is it LLM by Indians, right? Is it something that we care about building? And what do we mean by building? Of course, there is some detail to be said there, which I will, but at a high level, like built by Indians, stuff, right? I mean, Indian researchers, Indian community, and so on. Now let us understand what each of these mean, right? So when I say LLMs for Indian languages, this actually is possible today, right? And this people are already showcasing interesting use cases where if I have a problem in, say, suppose the PM Kisan bot, right? Let's take that as an example. I could have language interfaces at the front and end, right? So I am speaking in Hindi, it is getting transcribed, then translated and being passed to an LLM, which is good at English. Of course, GPT and all today are quite good natively in Indian languages, at least with the top 5-10 languages. But suppose they are not, and they're not natively recognizable, I can always take this translation route, give the query in English, the LLM will do the reasoning, maybe in a RAG setup where I have given documents from the farming or agriculture domain. And then I get a response, and I again do a language interface where I translate the response back to Indian language and do a speed sentence. Right? So this is possible today, and you would have seen demos of several such applications. Right? So LLMs for Indian languages is already doable without really worrying about building an LLM from scratch. The next is of Indian language. Right? So if you want to build a model of Indian languages, it goes without saying that you need Indian tokens, right? So you need data which has been collected in the Indian context, Indian articles on, like a natively written article on Battle of Panipat, a natively written article on Bharatnatyam or classical music and so on. Also Indian content, that means like, as I said, Bharatnatyam and other things, our history, our geography, so contextualized in India, right? So you'll have to create this content or curate this content from various sources and then sort of train the LLM on this content for it to become a model of Indian languages. Right? The next part is like by Indians, where in the second part, maybe you just create the data, don't worry about who builds it, and even let GPT consume that data or let Meta consume that data in its next version of Llama. But it still becomes a better model of languages. By Indians is where we do everything natively, where we build the model in India with the help of Indian researchers. Then we focus on what are the instructions that we would give, right? So when in India, and this is like a often repeated example of code mixing, right? If I want to use an LLM for summarization and I'm a Hindi user, I'm going to, most probably the instruction that I'll give is that upar wale document ko summarize karo, right? The word summarize will stay as it is, right? I would not say sankshet mein likhiye or something. So the instructions, what is the way in which Indians ask instructions? What are the things that we care about, and hence our instructions are grounded in those tasks and applications, right? Maybe we don't care about writing poetry, or maybe we don't care about, I'm just giving some random examples, right? So maybe we don't care about writing code while interacting with the LLM in Indian language, right? I'm not saying that we don't care, I'm just saying that there could be many such scenarios, and we need to really figure out what we care about and create instructions accordingly. Our preferences would be very different than the preferences of the Western world. For example, in an answer, we might be sensitive to whether it uses the aap or the respectful sort of pronoun, or it uses tum, or is it like what you would typically say to someone younger than you or a friend or something, right? So what are our preferences and how do they change across applications? How do we evaluate, right? How do we say that this LLM really works for Indian languages and Indian use cases? We may want to see if it works for IRCTC booking. We may want to see if it works for Make My Trip in the Indian sort of travel scenario, right? So all of this has to be natively created by Indians, because we may be in the best situation to sort of understand what really works for India, what is that India really cares for, right? So that is what I mean by for Indian use cases, of Indian languages, and by Indians. And another layer on top of this is like the timelines, right? So I think this is the short term. And I said this is already happening. This is like short term or now term, right? It's already been done. This is midterm. In the midterm, we need to make sure that the LLM efforts across the world, maybe Meta or maybe GPT, have enough Indian content to feed into their efforts so that these models become better at recognizing Indian languages and doing well on Indian languages. And this is the long term, right? Where we all get together, build all of this ground up, right? Really get to say 10 trillion tokens in Indian languages, 1 million instructions, preferences, all of this, right? I mean, you know the drill, you know the numbers that are required to get this done. And we all get together and do this. And this, of course, will be long term. This is not going to happen overnight, not going to happen in 3 months. But there are efforts to do this in the long term, right? So this is what I think of when I think about the term in the LLMs. And to summarize that, large language models should understand Indian languages, Indian contexts, and Indian culture, right? And these 3 boxes sort of align well with the different stages that are there in the training of a large language model. So when I say it should understand Indian languages, that means we need to get the tokens in during pre-training, right? When I say that it should work for Indian context, I mean that it should be fine-tuned for specific use cases or tasks which are more relevant for India. When I say it should recognize Indian culture or it should be aligned with Indian culture, I'm talking about the process of alignment where we understand Indian preference, right? So all of this needs to be done to build LLMs for Indian languages. Now, let's see how this is different from the English world. And here's a disclaimer, right? I'm going to underplay the effort that it takes to sort of get something like a ChatGPT out. I'm going to sort of almost embarrassingly underplay it. And I'm going to exaggerate a few things for Indian language. I'm going to do this deliberately, so I just wanted to make that disclaimer, right? And here I go. So if you want to build like a chat.openai, right, which we all interact with, then you have tokens served to you on platter, right? There are so many data sets already floating around, slim pajama, red pajama, some pajama, right, which had X trillion tokens already in the sort of bank. And now you just take that and build like a GPT-4 model. Again, as I said, I'm going to underplay things. And if you want to evaluate how it works, you have users like us, even Indians, who go and happily evaluate this. You happily interact with it in Indian languages. Otherwise, I see your hand has been raised.
Yeah, so Mitesh, we would request you to wind up in another 5 minutes if possible, so that we can have some time for the Q&A.
That's what I'm headed for. Yeah, and so we have readily available users who can type on the keyboard in English and start interacting. Sitting in India, we have been happily testing how ChatGPT works, right? And if you want to do a more formal evaluation, we have like a gazillion benchmarks out there already created and then repurposed for the LLM effort. And that's how sort of you get get models going out for English, right? I know about the examination that I do. But now if you come to the Indian world, right, and I want to build something similar, I want to build a chat.indicllm.org. The first thing I need to do is I need to start by creating tools for manual data, right? And over the years, we have been investing in these tools, Shunya, Kadbat, now Anudesh, which is Anudesh means instruction. So we are trying to build a tool which will allow us to collect prompts from people about specific tasks and domains that they might care about. Right? And we have to start here. This is not served to us on a platter. When I say us, I mean the entire community. We have to start here and create these tools from scratch. The X trillion tokens that are available for English are again not served to us on a platter. We have to build these pipelines. We have to build pipelines to curate data from the web, to curate data from audio. It's like an open secret that a lot of YouTube content has gone into training some of the largest LLMs out there. We have to build pipelines for curating PDF content. Now in India, when we started digitization, by digitization, we largely meant that take a paper and sort of make it an image and upload it in a repository, which is of course very useful, and of course very hard to do. But it's not fully digitization because these documents are still not machine readable. They are still as images. So you need to run sort of a OCR and document understanding pipeline on that to get out the content. And that's the reason we started this. Because now in the LLM world, if you want to really tap into all the knowledge sources for Indian languages, then we need to have content extracted from PDFs. Right? Using all of this and a lot more synthetic data, we will get to our Sangra, which is the trillion tokens, hopefully, that we need for training Indian languages. And then we train an LLM on top. Okay? But unfortunately, the story does not end here. I have more white spaces on the slide and I will fill them. Now, when people come and interact with an Indic LLM, they are not going to type, right? Because we can't type in our Indian language. We are not used to typing in our Indian languages. The keyboards are not very favorable for Indian language, right? So we would prefer voice as an interface. interface. So we need to build speech recognition models so that when users come and start interacting with our LLMs, we can recognize their speech and convert it into text so that the LLM can understand. Of course, we could also work on building audio LLMs, but that's a separate story. Then you would need transliteration, right? Because some of us may type, but we not agree. We do the romanization. I would type her as GHAR and then read the. Now, for the foreseeable, of course, we also need tools for toxicity and language ID and so on, right? Because we'll switch between languages so we can understand which language. Now, for the foreseeable future, I believe that a lot of knowledge would be locked in English. Right? We won't be able to replicate, unless we go to synthetic data route at scale. A lot of the knowledge of the LLM would still be in English. Right? So it would make sense that while you give it the query in the native language, you also give it the query after translating so that it has a better chance of understanding it in English. And then the LLM does its magic and gives the response. Now, once the response comes, you may again have to first translate it to the native language and then do a synthesis, right? Because again, we don't prefer reading in our languages. It's cumbersome, most people are not used to, while we're all good at speaking and listening to our language, right? So all of this essentially around the basic LLM, right, which is the trillion tokens and training the next token prediction model. And I'm exaggerating, but yeah, all of this basic stuff around it, which is tools for data collection, pipelines for scaling or crawling data at scale or creating data at scale, the peripheral foundational technology of speech recognition, translation, speech synthesis, OCR, all of this needs to really be built if you want to make LLMs for Indian language, right? So that's all I wanted to end with. I'll take a pause here and I would be happy to take.
Thank you, Mitesh. Thank you for that excellent and insightful talk. And it's really inspiring to know all the work which your group has done in the AI for Bharat. So I guess there are quite a few questions from the audience as well as the panelists. So I will try to summarize a few questions. So here is the first question from Vidya Kamakshi. So the question is that when you are collecting web data by crawling the web, there are sometimes Indians try to write in mixed languages such as English. So how do you handle such cases?
Yeah. So I think that's a very relevant problem that we have. So taking a step back, right? So at least for machine translation when we started, most of our focus was on translating formal content. We assumed that you write in good English and you want the translation to be good, right? So all of our data has been there. But now, as our models are getting deployed in applications, especially in chatbot kind of applications, we are hearing that no one wants to see the translation that Pariksha Kendra pe aapke परिचय पत्र की जांच की. They want exam center pe aapka ID card check kiya jaye. And that's what they understand. And this is like code mix version of the pure Hindi center. So now we are trying to see how to take our base models and sort of adapt them for this code mix output. We don't have a solution yet, but we recognize the problem, and it's a very important problem that we solve. That is how it shows up in translation. It also, of course, shows up in speech recognition. There, fortunately, as we are going and collecting data from the ground, people naturally speak in code mix. Right? They say things like jolly, friend, and all of these things. So we are naturally getting that data. So we have like a repository of sentences now, which are transcribed and contain code mix content in the native language, right? And we hopefully will sort of take that and try to translate it to English so that we have this pairs of code mix native content and English, and then we could use that to improve the translation. Right? So we have been focusing on it. I think we are not quite where we want to be right now, but this is a problem of interest and we definitely work towards doing something about
it. Thank you. Like apart from that, there are one more question from Sonali Batra. There are some suggestion, rather say. So she has a suggestion that it might be possible to use a small amount of manual data to create a more synthetic data using something like GANs, and then use them from training and LLMs, and then train the LLM. Also use the LLM parallelly using web crawl data and then combine the two. And also she is suggesting that for these translation purposes or for this manual data, we can use some kind of crowdsourcing, and like the government can actually make some kind of or make some kind of interventions to so that people can provide some translation directly. So like any thoughts on this?
I'll first, it's India. So the government actually has a portal called Bhasha Dan, where you can go and contribute to different language activities. One of them is translation. In my view, it has not really taken off the way you would have hoped for, right? And of course, I mean, multiple efforts across years, some of which I have personally been part of. Crowdsourcing in India doesn't work, right? And the biggest proof of that is the Wikipedia, state of Wikipedia for Indian, right? So perfectly crowdsourced effort. Uh, Somehow we have not been able to figure out the right incentives. And I don't say that I've given up on that problem. But I think we have to keep revisiting that and design the right set of incentives that people really contribute. And also, some of these tasks are cognitively challenging or high skilled jobs. I mean, not everyone can translate. I'm a native speaker of Hindi. I've learned Hindi in school as a subject. But if you give me a newspaper article in English and ask me to translate, I can't do that. Struggle. I would end up putting a lot of code mixed content. It's a very requiring skill, so it's not something that the crowd can do, the general janta can do. So you really need to be mindful of that also. But having said all that, crowdsourcing is one of my pet things to do, and I think we should really reinvent that and see whether we can align better. So that's the answer. I think question. The first,
Okay.
synthetic data. I think multiple efforts across the world are showing that now synthetic LLMs are very good at generating synthetic data, which is almost human quality. Of course, there's the LLMEs effect, just as there's the translation ease effect, where now you will train on junk generated by the LLM, but of course it's not junk. A lot of the data is quite good what LLMs generate. That needs to be balanced. But having said that, we are definitely considering taking that route, where we sort of create synthetic data from Indian languages for Indian languages. One important area where that is useful is that we take knowledge dense content, like content of history, geography, STEM, and translate it to Indian language. Right? Because it is very hard to ground up now create this data in Indian languages with human effort. And as the translation models improve, I am hoping that the quality of translation may be good enough for feeding in the knowledge. On top of that, you might need this creamy layer of very natively high quality written content in the language, which will teach the model about the language, but to teach the model about the knowledge of the world, which is where a lot of magic of the LLMs happens. I think synthetic data may be useful. Right? And could take that route, but very initial efforts. And of course, across the world, there are many efforts.
Okay. Thanks a lot, Mitesh. And there is one more question, or rather suggestion from Durga Bhavani about like including the different dialects of a language, also including the variants or variations of a language across the district wherever like the language is spoken. That can be really useful. That's a suggestion. And a related suggestion like this one is from Srujana is like we can also consider uh, how English is considered by is spoken by Indians in different parts of the country and so on. So maybe it may make sense to focus on the transcription of of English language spoken by Indians from different parts of the country. So any thoughts on that?
Uh, we have benchmarking. So what we have done is we have collected English data from people across the country, like a very small benchmark of 20 hours, but it has like an Assamese speaking English, someone from Kashmir speaking English, someone from Rajasthan speaking English, and so on. And we were benchmarking the Whisper English model. And the WERs were less than 10, right, which in my opinion is quite good. Of course, there is further evaluation to be done because a lot of speech recognition start breaking for telephonic content, like it's 8 kilohertz and so on. But at least my opinion is that for English, the Western model is quite good and it works really well out of the box for multiple Indian accents. Right? And we also use it for transcribing NPTEL videos, whereas you can imagine the faculty who are recording these lectures come from different parts of the country, have different accents. But of course, it's a very conveniently sampled set of people because they come from a particular education background, speak, at least pronunciation errors are not there, accent errors may be there. But then also it works well, right? So I do agree there is value in investigating this further. But my current sense is that for English, we are at a stage where we are not in the red zone, right? But for some of the Indian languages, we are really in the red zone. Let's try to first bring them to the orange or sort of light green zone and then sort of think, reassess whether we need to now look at English again. Right?
Okay, got it, got it. Like one more question. This one is from Indrajit. So, you mentioned the word error rate as an evaluation metric at one point. So, Indrajit is wondering if this word error rate is not necessarily a right evaluation measure for many practical applications. Because when you are using word error rate, it treats all the words as the same. But we know that all words need not matter equally when we are trying to understand. I mean, certain words are more important than the others, and some of the words are easier to guess. So, should word error rate be the right measure? Any thoughts?
Definitely not, right? And again, just as I had sort of had two categories of translation applications, even for speech recognition, I would say two categories of applications. So one is like the subtitling word, right? Where you have a content like you use broadcast and you want to subtitle it. Their word error rate makes sense because you want very high fidelity, right? You want everything to be transcribed perfectly. But then there are these transactional applications where again I am trying to just get the transaction done. And as long as the main entity, which is 100 rupees transfer from account number X to account number Y, bank name, all of this has been taken properly. And some parts have been sort of have an error as these are the more important entities for that transaction. I would still say that it is good, right? And then also in word error rate for Indian languages, what happens is we are seeing a challenge with home mixed content. So you would have said electronics, that electronics item. Now, what is the spelling of electronics in Hindi? It's just what you decide, or I decide, or someone decided, because it's not a native word. What is the spelling of items in Hindi? Right? So the transcription may have a particular spelling. The model may have produced a different spelling, which is perfectly fine, right? But it will still get a word error, right? So we do see a lot of challenges in using WR as a metric. But just as is the with blue and green, right? I mean, people have been criticizing it for 20 years, but still it is the most reported metric to date because people have sort of built this intuition on what a blue score of 20, 30 means. And they're able to use that intuition to make progress. Right? Similarly, people have built an intuition of what WR of 20 means, along with the challenges that we spoke about. Right? And we still make meaningful progress by tracking that number, right? Although it's not the most ideal number, it's a good approximation. But yeah, clearly for Indian languages, there are many challenges.
Uh, Thank you. And one more question here. This is from Shivkumar. This is a more general question about how we can spark a larger ecosystem of research and applications based on the foundational work which you have done for AI for Bharat.
So one hope that we have, right, is that 10 years back when, for example, right, when students do their PhD, a lot of them have been working on English, right, because that is where the data sets are. If you want to publish, you have to show results on a data set. But now that we have so much of Indian language data being created in the ecosystem, not just by us, but there are multiple such efforts across the country, I hope that there is a shift that our PhD students now, when they are working on language technology, they focus more on these data sets. Right? And this will sort of increase the number of papers in conferences which come out on Indian content that will sort of have this snowball effect. People will start realizing that, yes, I can publish by working in the top conferences, by working on it. So we hope that some of the open source models, some of the data sets that are being created in the countrywide ecosystem, not just in AI for Bharat, helps in sort of snowballing, has a snowballing effect where people use whatever is out there in the open source and build on top of that, analyze some of the models, find shortcomings, analyze some of the data sets, create better benchmarks which can help in understanding the quality of those data sets. So I hope that should happen. We should see that happening in the future.
Okay. And one last question from Gautam Prof. We are almost out of time, but would you say that Indic Whisper today competes with the OpenAI Whisper for transcribing Indian language speech?
We have not even evaluated that. I don't think OpenAI does any good job of transcribing Indian language, at least whatever we have evaluated when OpenAI had come out. But yeah, let me answer this question in 2 months from now.
Okay, sure. Thank you. I will be looking forward to the answer. So thanks a lot, Mitesh. It's a really interesting and insightful talk, and also thanks a lot for all the attendees who put in their questions. I apologize sincerely to the all those who put in your questions, but we could not answer them due to the time constraint. But since you have posted it, we will try to answer them by text. I guess, Mitesh, you have access to the Q&A widget, right? So I would request you to type the answers if possible. Now we would move on to the next event, which is the emerging applications of the emerging applications of data science in India. So I am now going to share my screen and hand over the control to Manjira, who is
Hi, thank you, Abhay, and good morning, everyone. So I am Monjira Sinha from TCS Research. So in this session, we have 4 short talks by is my voice audible? I believe there is
yes,
some.
your voice is audible.
Yes.
Thank you. So we have 4 short talks by eminent domain experts to showcase the transformative impact of artificial intelligence in the sectors of health, the energy management, healthcare, accessibility, climate modeling, and remote sensing. So we will start with the future of 24/7 clean energy with Gen AI by Srinivasan Iyengar and Shivkumar Kalyanaraman. So she is CTO, Energy Industry Asia at Microsoft, and previously he was the Executive General Manager of Growth Offerings at GE Power Conversion, responsible for the new line of business development in e-mobility, commercial and industrial solar, and digital and AI innovations. And Srinivasan Iyengar is a senior program manager at Microsoft Energy Industry. His interests are in energy systems, distributed systems, sensing, IoT cloud, and edge computing. And just before we start the talks, we will have all the question answers at the end of the session. So participants are encouraged to type out their questions. So over to the talk. Thank you.
Thank you, Manjira. So now I'm going to play the first talk by Srinivas Iyengar and Shivkumar, both of them from Microsoft Research.
Hello, everyone. This is a talk on the future of 24/7 clean energy with Gen AI. I'm Shiv, and with me is Srini. We are both from Microsoft Energy Industry Asia, the CTO of this. Next slide, please. This work was done with lots of our colleagues who've been listed in the previous slide. So the broad long-term context is that climate change involves bending the greenhouse gas emissions curve, and a huge contributor to greenhouse gas emissions is energy, over 70%, closer to 73 and more. And a huge vector in the energy decarbonization is to electrify the end use of energy rather than having combustion of fossil fuels to drive energy and therefore have carbon dioxide emissions. And also on the supply side of the electrons, you're going to replace fossil fuel derived energy sources with renewable energy sources. Now, what's interesting is that the cheaper forms of renewable energy are increasingly solar and wind, which are quite volatile and dependent on weather. And that poses a problem. It's also not controllable. So end of the day, you have to match demand and supply. And that's why the role of digital to manage and match these and also orchestrate other flexible energy resources is very important. Next slide, please. So in summary, the renewables transition and therefore its impact on climate change can be accelerated only if renewables not just get cheaper, such as through hardware and policy and finance, to getting smarter. which means being able to manage the impact of volatility of solar and wind, and the fact that the rest of the resources on the grid are going to decline if you're going to expand the share of solar and wind. Therefore, solar and wind and other forms of renewables need to get smarter to manage their own externalities that they are imposing on the grid. So this is actually a digital problem and an AI problem as much as it is a hardware and a software problem, right? So hardware, software policy, finance, supply chain, those were the drivers earlier. Going forward, it's going to be far more AI driven. Next slide, please. So continuing the story, if you look at grids and the approach to managing the grid and deep renewable integration, the building blocks are to be able to measure demand and supply and match them 24/7 to have a data foundation for matching and settlements. And then once you have that, how do you forecast the demand or supply side so that you convert pure unknown unknowns to known unknowns or risk and characterized unknowns? And then once you have that, you can take decisions under the residual uncertainty, and you can orchestrate assets, do energy trading. And then ultimately with Gen AI capabilities available, how can we go towards the rich remote operations centers, much more natural interactions, the ability to use the composite of all the data and insights for being able to scale up remote operations where you have renewables and so on are going to be much more scattered, and the points of demand are also going to be scattered. And ultimately, cloud itself can be a flexible energy resource. Next slide, please. So, consistent with this, the Microsoft approach has been to have a set of innovation frameworks, or a set of frameworks we call energy AI frameworks, as a foundation for this energy transition. And this is well matched to what I showed earlier, 24/7 matching, forecasting and time series, decision management and optimization, and then two areas of multimodal Gen AI, where one involves front-end applications and orchestration of models and so on to drive easy applications where AI drives AI, and the other end is on interfaces to various sorts of knowledge artifacts called Enterprise Knowledge Advisor. Next slide, please. Over to you, Srini, on talking about the forecasting framework.
Yeah, hello everyone. So in this slide, as you can see, we are talking about the forecasting framework. Now, the key endeavor here has been to allow forecasting of different entities that are relevant in the energy domain, such as demand forecasting, solar and wind forecasting, and price forecasting. One more thing that we have achieved is that we have a common interface which allows us to do forecasting at different granularities and different time frames. The framework is quite flexible as it allows for integration of different types of deep learning time series models along with the traditional time series forecasting models. And this allows us the optionality in the future where newer models may beat the existing models that are state of the art. One more thing that we noticed while building this framework is that the fusion of different types of data, everything from third-party weather data to irradiance data, and some domain expertise that are relevant to some physical setup related to that site or some market dynamics, along with the on-site SCADA data, can be fused together to generate superior forecasts. Here is an example of our forecasting framework applied to an open source data from a wind farm in south of Australia. As you can see in the top left corner, we applied TFT, which is an open source state-of-the-art time series forecasting model without using any exogenous variables. As you can see, the error is a bit higher. When we apply a slightly better model, which is a DeepMC model, our Microsoft's own in-house time series model, we get a relative improvement of around 15%, right? But it's not just about better models, it's also about using other exogenous variables, or what technically is called past and future covariates. And if we fuse those external data points, the improvement is quite significant. We get a 40% relative improvement when we use not just a better model, but also better third-party data and other exogenous variables. So many years ago, there was a paper which talked about the hidden technical debt that is involved in building ML systems. Typically, the core ML code is a very small part of the overall ML systems, because there are many other aspects such as verification scripts, data collection pipelines, configurations, serving infrastructure, etc. So looking at this technical debt, we looked at the entire life cycle of time series forecasting problem, everything from modeling to production. And we have several innovations along the way so that the effort required to set up a time series model is reduced drastically. Everything from automated infrastructure and environment setup, to forecasting problem setup, handling multiple models, and having a deployment strategy which can allow automated MLOps. Another framework that I want to quickly talk about is called a decision management framework. Essentially, this allows handling portfolio of different resources such as a solar farm, wind farm, a storage battery, or a hydro farm, hydro plant. And what we do is that we have a digital twin abstraction for all these different type of assets. And by orchestrating them and applying optimization techniques on top of them, allowing them to have optimization techniques on top of them, we can have several industry patterns that can be enabled. Everything from battery arbitrage, microgrid, multi-market value stacking, and also network of dams, which allows us to manage multiple hydro dams, both upstream and downstream, simultaneously to have much more informed decision making. Here is another example of how we can apply decision management framework. Here is a use case where we have multiple resources in our portfolio, a solar farm, a wind farm, and a pumped hydro setup. And in many markets around the world, in many geographies around the world, they allow for participating in multiple markets, such as day-ahead markets where you have to place your bids a day in advance, intraday markets where you have to place bids an hour or two before the delivery time, and finally there is the actual delivery of the electrons that you have to do. What this setup allows us to make sure that we, while we bid in the day-ahead market, adjustments are made in the subsequent intraday markets so that the penalties that you may have to face due to non-delivery or excess delivery of power can be mitigated. With this, I'll hand over to Shiv again.
Thank you, Srini. So I'll quickly cover what we're doing in GenAI with a multimodality as a focus. As I mentioned earlier, how do we enhance collaboration is one focus, which is what we call multimodal GenAI orchestration, MGO. And how do we have richer interfaces to a variety of knowledge sources, which we call MECA, Multimodal Enterprise Knowledge Advisory. So these are a couple of frameworks. And this mimics the human ability to sense in different ways, interact in different ways, as well as have multimodal reasoning based on perception of each mode. Next slide, please. So first, in the multimodal GenAI orchestration, the idea is that you can get inputs from multimodal natural ways. Again, in the future, it will be speaking and simpler ways. Then AI helps you plan and build a plan. And then with each step in the plan, it will call other AI tasks, which could be ML tasks, it could be functions and so on, or even human inputs. And these can be organized in a task graph. So currently, we are working with simpler task graphs and simpler structures. But going forward, the ability of AI to do much more richer reasoning, can help us build more complex task graphs. So the idea is that here this can help democratize with AI and where you give inputs and out comes a solution. So that's the general approach here. Next slide, please. So here's an example where you're giving multimodal inputs with a conversational input and some pointer to, in this case, an image, and then out comes, an annotated image. But more importantly, based on that annotated image and a plan for that, it sends out automatic action. So this is an entire cyber-physical system where you're starting from sensing to understanding, perception, reasoning, and ultimately decisions. Right. So this is a simple end-to-end flow. You can have many other complex flows in the future. Okay. Next slide, please. So in multimodal enterprise knowledge advice and LLMs and so on, and then front-end interfaces of chat and so on. But more importantly, the quality of what you can do with retrieval augmented generation or other more complex forms of agentic RAG and so on is dependent on the quality of ingested data and how do you convert things from their raw form to something which are better represented and amenable to these RAG pipelines. So that way now you can start asking more complex engineering queries that touch multiple sources of data, domain-specific queries, analytical queries, etc., or non-functional aspects like role-based feature access and other profiles, etc., right, which are enterprise kind of features. So this is a framework that facilitates all of these while allowing this area to progress further as we have newer and newer innovations, whether in the open source domain or in our domain. Next slide, please. So there's an example of how we can put all this together. You can have a multimodal enterprise knowledge advisor providing insights from the classic sources of unstructured data, then you can have classic time series data coming through PI systems, and you can have time series anomaly detection and root cause analysis. And then you can have digital twins, and then you have an interaction space where people can talk in a multilingual way, and so on, right? So you can have like a mobile-based view of this, or you can have like more of a metaverse interaction space, right? So this is just a view of something we've done with a customer on showing how the future can evolve, right? With that, we'd like to conclude. Last slide. Thank you very much, and we look forward to your questions. And these are our LinkedIn profiles. Thanks. Bye.
Thanks, Shiv and Srini, for this wonderful talk. So we will move on to our next session, which is on the building data science driven healthcare systems preparedness, lessons from COVID-19 and AMR by Dr. Tavpritesh Sethi. Sorry. Dr. Tavpritesh Sethi is an associate professor in the Department of Computational Biology and the founding head of the Center of Excellence.
Good morning, and thank you for this.
IIT Delhi. So just one moment. His area of expertise lies at the interface of computer science and healthcare. And Dr. Sethi researches in the domain of critical care and community medicine, applying machine learning to that and big data for clinical decision support. Over to the talk of the
Opportunity to present our work in the Data Science in India IKDD workshop. My name is Tavpritesh Sethi, and I work at IIIT Delhi as an associate professor in the Department of Computational Biology. I will be talking about the challenges and opportunities that we have in data science and AI in healthcare in general, and how is our lab engaged in solving some of these challenges. I usually like to give this example where this particular group based in Canada, it's a company called Blue Dot, sent out warnings of an epidemic that is spreading fast across the globe 10 days before the WHO alerted and 7 days before the CDC alerted the world. If you can see the date on the top, you will notice it is early 2020. The Blue Dot algorithm actually made use of data that are non-traditional. So data from flights and integrated with epidemiological data were used to create these predictions. More interestingly, you can see that it was still not called the coronavirus. So we did not have a sense of what virus it is. Is it COVID, coronavirus? It was still called the Wuhan virus. The founder of this company, Dr. Kamran Khan, is a pediatrician turned data scientist. And this is not just one isolated piece of evidence that his company created. They have published such evidence repeatedly based on data mining efforts in their company. For example, for the spread of Zika virus in Brazil, which was communicated in the Lancet, and also for Ebola and others. So this is just an example for how data can actually help us build evidence-based health systems preparedness using data science. This is another example which made use of language models to understand the DNA of the virus. So basically making use of language models to model the viral DNA evolution and its escape from our immune system to understand whether a certain virus will become more dangerous and will attack, let's say, the human species. Now, this made use of, as you can see, a semantic embedding encoded using standard grammar models, and then was used to understand how the virus evolution happened, and was published in Science early in 2021. The third example that I would like to quote in general, and these are just some key examples that we've seen over the last few years, is basically making use of reinforcement learning based interventions that can be used to guide treatment strategies in the ICUs. And here in this case, reinforcement learning was used to guide fluid interventions in the ICUs by Komorowski et al. The reference is available. It's a paper published in Nature Medicine in 2018. So I wanted to give you these three very distinct examples. One which is based in public health and data science, second which is based in genomics and large language models, and third that is based in hardcore interventions and making use of reinforcement learning to guide interventions in a very clinical ICU sort of setting. But is it easy to develop such interventions or insights for the real world solutions? There are some very persistent gaps and real gaps in the real world. The first gap is obviously data. We don't have enough data in most of these clinical and public health settings to train models. Second is knowledge. Data by themselves are not enough, although they are key, but we need trained people who understand and can bridge both data science and healthcare. It can be public health, it can be clinical medicine, but we need the bridge expertise. Also, from data, we need to actually uh, create useful knowledge that can lead to the third key component, which is addressing the policy gap. By itself, knowledge is not enough. We need to create interventions that can serve as policies and basically lead to improvement in health status of individuals or population. So we have policies, for example, fluid administration policy in the ICUs, or uh, intervention policies in the public health settings, for example, zinc administration to prevent diarrhea, or vaccination strategies for COVID-19, right? So, or antimicrobial resistance policy for public health. So, these three real gaps have to be addressed. So, this will basically serve as a pivot to switch to our work and how are we addressing some of these gaps. So since 2015, I'll start with an example in the clinical settings in the ICUs at AIIMS, in the pediatric ICUs at AIIMS, where we're solving all these three gaps. We recognize that ICUs are rich sources of data. They generate about a gigabyte of data. Our ICU generates about a gigabyte of data a day. But these data were routinely lost. So there was a data gap. So we put in our IT systems to first warehouse these data. And now we have more than 2 million patient hours of continuously monitored data in the pediatric ICU at AIIMS New Delhi, which then helped us to build the prediction models and to address the knowledge and the policy gaps. The first prediction model started coming in 2019, which this paper in Scientific Reports talked about, basically using computer vision models to predict which baby is going to crash in the next 12 hours. And we use some simple models based on computer vision, which basically said that can we look at the temperature gradients across the body of the baby and predict is the baby going in shock or the child going in shock or not. Some of these models have been actually validated in more than 200 ICU settings. And these are ICUs for which data are publicly available, mostly from the US settings, like the MIMIC database, which is linked to uh, uh, the Beth Israel Deaconess Hospital ICU. And in collaboration with MIT, they created this MIMIC resource. Also, the eICU resource, which is more than 200 ICUs that make use of the Philips monitoring system. So we show in this preprint, which is currently under review, we show that our models actually work for these more than 200 ICUs, which are cardiac, cardiac surgical, cardiothoracic, medical surgical, neuro, and so on, with more than 90% accuracy in predicting shock 12 hours ahead of time in this case. And we believe this is key because for data science in healthcare to actually be deployed, it needs to be generalizable to various settings. We deploy some of these models as web applications so that we don't only have these as academic exercises, but we can prospectively validate some of these models in the ICUs, and clinicians can actually test it and see whether they're working or not. I'll switch gears to another work that we did in the genomics of COVID-19 viral evolution, again using language models and machine learning. Here we ask the question, can language models like word-to-vec models, and we also tried with large language models in our recent work, can they actually understand the grammar of the COVID-19 sequences and then make predictions about um, when will or how will the future spikes look like? And here we were fortunate to have data from more than 17 countries, more than 2 million sequences, 3 million sequences for which data were available and models could be trained. And these grammar models were then basically trained to predict outcomes such as the case surges during this time. And the paper is published in Frontiers in Genetics in 2022. The references are listed below, you can visit. But what we saw was the entropy of these grammar, the rate of change of grammar of certain regions in the spike region was actually quite predictive of case surges up to 2 months in advance. The red line here is the entropy signal, the gray line is the cases. And you can see that there's a pattern which was true for more than 7 countries, which can be seen here, all statistically significant, and also mined in various statistical and machine learning analysis. For example, the blue line here precedes the red line by 2 months. This was captured in the detrended cross correlation analysis as well as the statistical analysis. And in the hindsight, it makes sense because we know that the virus explores the grammar patterns and then exploits them. And when it So this work is published. You can look at this online, but we also deployed this as a dashboard called the strain flow dashboard because we believe in making our research models publicly available and also utilizable by policymakers. This was also communicated to various policy agencies across India. We also solved the data gap by building data, um, integrated data resources. And this is one data resource which we built for COVID-19, where the previous example on what we call strain flow is available publicly. We're extending this to cancer, so you can actually go and visit our site. It's called federatedhealthplatform.tavlab.iitt.edu.in, where you'll find a lot of data sets which have been mined by our group, and then we ask questions, what data sets can be combined together to answer questions. Finally, in the last 1 minute or so, I'll say that antimicrobial resistance is the next pandemic that is already here. We in India don't hesitate in popping antibiotics for even the mildest sore throat infections, which is a practice which should be curbed. So a recent paper published in Lancet Regional Health showed that there are alarming rates of antibiotic resistance growing in India. For example, imipenem resistance, which is a key antibiotic used to treat Klebsiella, E. coli, gram-negative infections. It has been growing at the rate of 0.2% month on month in sepsis, which is bloodstream infections, and 0.02% month on month in urinary tract infections, which is alarming to see. So we basically conducted data science experiments to understand these trends and decompose, and then also understand what is the lead lag relationship. Can we predict which antibiotic will become resistant looking at some other antibiotic? For example, here we are looking at amikacin to predict the rise of cefazolin resistance. So again, the same kind of lead lag analysis gave us clues on how can we create better surveillance mechanisms for antibiotic resistance in India. We also put these data in the context of the achievement of sustainable development goals and show that curbing AMR is key to achievement of SDGs or Sustainable Development Goals. Here we show that in both in sepsis or bloodstream infections and urinary tract infections. And the same findings pop up, which are shown in the highlighted nodes in this Bayesian probabilistic graphical model learned from data. And the the paper is referenced below, so you can read more about this. We are rolling out some of these initiatives in one of our recently awarded Trinity Grant Challenges, and I'm happy to invite collaborations to join hands to solve some of these challenges in antibiotic resistance or sepsis in the community levels. So to summarize, data science in healthcare should actually be built for nuanced context and integrate context. It's not just about downloading a data, it is working with the data communities where these data get generated. So it should connect with domain understanding as much as it is about building technology advances. It should generate knowledge, representing knowledge in models, and build all the feedback from users so that these systems can iterate and visualize outputs. Finally, they should solve some real world problems, and that's what we always aspire to. I hope I was able to communicate some of our research and overarching research that is happening. And with that, I would like to acknowledge our group, and I'll be happy to take questions. Thank you so much.
Thank you, Dr. Taf, for this wonderful talk and very informative on how we can use the potential of artificial intelligence for serving the community for healthcare. So moving on to our next talk, I would like to welcome Dr. Tirthankar Dasgupta, who will be speaking on language technologies for accessibility. So Tirthankar is a senior scientist at TCS Research and Innovation Labs in the Data and Decision Science group, and he works in the domain of applying state-of-the-art artificial intelligence models for different real-world applications, such as in the finance, healthcare, and in the accessibility domain. So over to the talk, and thank you, Tirthankar.
This is Tirthankar Dasgupta from TCS Research. Today my topic of discussion is on AI for accessibility. The technology has changed the way we used to interact with others. Conventional ways of long-distance communication using letters, postcards have been replaced by mobile-based SMS, emails, WhatsApp, etc. Newspapers or other print materials are increasingly accessed through web-based medias. Most of the public services like banking, postal services, shoppings are gradually transformed into mobile web-based services or maybe cloud services. However, the question is, are these services accessible to all? How do you think a person with visual impairment can use a mobile to type text or use a web-based interface to read newspapers? How do you think that a person with hearing impairment can seamlessly go to a bank and perform his or her desired tasks? It is difficult. However, despite limitations, people with disability can use the digital interfaces using technologies known as assistive technologies. Assistive technologies actually refers to the design of products, devices, services, or platforms to be usable by people with disabilities. It aims to ensure that everyone, regardless of their physical or cognitive abilities, can access and use a system or environment effectively. Accessibility is a critical component of inclusivity, recognizing that barriers, whether physical, digital, or informational, should be minimized or eliminated to allow equal participations for all. Accessibility is not just a moral or ethical obligation. It is more than just a convenience. It is a fundamental human right. In a world that increasingly relies on technology for education, employment, healthcare, and social interaction, ensuring that everyone, regardless of their abilities, can access these resources is essential. It is critical. It is a critical requirement driven by several key factors, including legal compliance, global adoption, drive for innovation, and of course business growth. So in terms of legal compliance, many countries have already established laws and regulations that require organizations to make their services and products accessible to people with disabilities. For instance, consider Americans with Disability Act, or maybe European Accessibility Act, and similar many other legislations in other countries that mandate accessibility in public and private sectors. And obviously, non-compliance can result in significant legal consequences, business loss, including fines, lawsuits, and reputational damage. In terms of business, actually designing accessible products expands market reach. By making products and services accessible, business can tap into large and often undeserved markets of individuals with disabilities. This not only opens up new revenue stream but also enhances brand loyalty and customer satisfaction. Now, language technologies or generative AI in general plays a pivotal role in fostering inclusivity by breaking down communication barriers that might otherwise exclude people with disabilities from fully participating in society. Assistive technologies such as screen readers powered by text-to-speech technology enable visually impaired individuals to access written content on the web. Similarly, automatic speech recognitions or ASRs can help these target users to provide input in terms of speech instead of standard input devices like keyboards and mouses, which are difficult for a person with visual impairment to control. Also, ASRs can help those with hearing impairment by converting spoken languages into written text, facilitating real-time communication and access to multimedia content. Secondly, machine translation systems or language generation models, multilingual support tools help bridge language gaps, making content accessible to non-native speakers and those with language-related disabilities. This is particularly important in global context where language diversity can be a significant barrier to information access. Further, simplified text generation or text simplification techniques, text summarization techniques, personalized summarization tools are extremely beneficial for people with cognitive disabilities, providing them with easier to understand versions of complex documents or long documents. This ensures that everyone, regardless of their cognitive abilities, can engage with important information. So by integrating these technologies into various platforms and services, we can create environments where everyone has equal opportunities to access information, communicate effectively, and participate fully in society, regardless of their physical, cognitive, or linguistic abilities. Now, most of the state of the art that we have seen so far are primarily based on English languages. However, a lot of researches and efforts have been made is going on building technologies for Indian language systems. For example, Songjog is a verb-driven iconic interface primarily used by people with severely speech and hearing impairment or cerebral palsy, where they communicate using a set of icons. So through this interface provides iconic input, and this interface is integrated with Indian language NLG engines associated with the systems. So once these a person select certain images, the system can directly generate natural language sentences through those images. Similarly, for people with visual impairment, Sparsha is there as a comprehensive Braille transliteration system. The Sparsha has a capability of transliterating almost all the Indian language text into Braille. And from there it can be directly printed out using specialized Braille printers. However, a lot of challenges still exist, and there are many open problems are there with respect to developing these technologies. For example, Sparsha is primarily based on monolingual languages. But what if a text document contains code mix data, where multiple languages are present? How to transliterate the text in that form? Secondly, how to effectively transliterate complex mathematical equations to Braille? How to effectively describe mathematical or geometrical figures for students who are visually impaired? So these are some of the open problem on which people are still working on, and people are banking over these generative AI techniques to solve these issues effectively. Another very interesting problem on which we at TCS Research are also working is to develop machine translation system for for hearing impaired people, which is a text-to-sign language translation system. So these kind of machine translation systems are in general complex, not only in terms of their unavailability of data, but also in terms of the modality. So here in a text-to-sign language machine translation system, so the input is a text and the output is a sign language representation of the text, which has to be in a different modality. So sign languages are typically visual, spatial, natural language, because the signers uses their hands, arms, and facial expressions to communicate. Signs can be one hand signs, two hand signs, manual, non-manual signs, and so on, and they can be simultaneous in nature. This makes the problem even more complex to handle. So there can be many different techniques through which sign language machine translation system can be built. One of such technique is that we are employing is taking an input English sentence and then extracting the semantic components of the sentence and representing them in the form of an interlingua, in the form of a recursive frame structure, and from there we generate the output sign language glosses. So once these glosses are created, then these individual glosses are then further transliterated into a kind of notation system, which is called hemnosis notation system. So this hemnosis notation system actually incorporates all the critical phonetic information associated with the sign of that particular gloss. For example, in order to sign a particular word like next or weak, what should be the hand shape, how the hand has to be moved, what should be the palm orientation, what should be the location of the sign, and so on. So all these informations are encoded within this hemnosis notation system. Once this hemnosis notation system is generated, then it is passed to a synthesis module that takes this hemnosis and then try to automatically synthesize this sign language through an animated avatar. So I'm not going into detail of how these things work, but I just try to give you a brief overview of how these machine translation system works. So overall, I mean, in summary, what I'm trying to say is that accessibility is required not only to meet legal obligations, but also to ensure global inclusivity, drive technological innovation, and support business growth. By embracing accessibility, organizations can create more equitable society while unlocking new opportunities for success and innovation. Language technologies plays a pivotal role in making digital content, communication, and information accessible to people with disability, thus fostering inclusivity in society. By leveraging advanced tools like generative AI, speech recognition, machine translation, language technologies can bridge the communication gap and ensure that everyone, regardless of their abilities, can access and interact with digital resources. So I would like to stop it here right now. Hope you have liked this presentation, and I am happy to answer questions. Thank you.
Thank you, Tirthankar, for this informative talk that how artificial intelligence can impact and make impact in making our environment more accessible and inclusive. So moving on to our last talk for this session, it is on machine learning and Earth observation applications for climate impact by Dr. Varun Gulshan. Uh, Varun leads the Earth Observation Sciences team at Google Research, which is part of the climate and energy efforts within the applied sciences. His team's mission is to use machine learning and Earth observation imagery to solve geoscience research questions motivated by applications in climate mitigation and adaptation. So over to the talk, Varun, of the screen.
Good morning, everyone. Today I'm going to talk to you about my team that works on machine learning and satellite imaging for climate impact applications. Quick background on myself. My background is in computer vision, machine learning, and for a long time I've been interested in interdisciplinary applications, a little bit outside the software domain. And so I've spent some time working on healthcare for many years, and the last 4 or 5 years have been on working on climate applications and satellite imaging. And this is the team that I lead, and the broad mission of our team is to use machine learning, Earth observation to solve geoscience research questions. And geoscience is anything around the physical world, natural world, volcanoes, hydrology, climate, agriculture. So it's a broad field. But a specific focus right now is on climate mitigation and adaptation applications. And I'll talk to you about an example of each that we have worked on in our team in the past. But just some context, I mean, a lot of you might be aware, but I just want to explain a high-level picture of what's the situation with climate change. These are the various drivers of broad categories of emitters. Electricity and power is just one of them. You will be also, like, land use is something we don't think of, but it's actually one of the biggest contributors. And there's heavy industry, so some things might be a surprise to you, and aviation is not as big, but obviously 5% is a huge amount. The total goes to 59 gigatons a year. So that's kind of the broad picture of the different sources of emitters. And the food agriculture land use category especially has a lot of remote sensing applications for monitoring emissions. But there's interestingly work we can do in the electricity generation, which I'll talk about around solar potential estimation. And this is the adaptation side of things. That, I mean, we are all experiencing lots of natural disasters, and with increasing frequency, it's hard to directly attribute, but there's clear consensus on how extreme weather events are causing this, and floods is something we're all familiar in India, obviously. So that's definitely a clear thing. But extreme temperatures as well, like the heat waves that we have been experiencing. So how do we adapt to these in a better way? That's kind of the broad goal of adaptation. We are also trying to fight climate, but we have to adapt at the same time. And this is just kind of some data from the WHO, which puts the scale of the problem in perspective. So now coming to kind of the technical side of my presentation, I'll talk about two applications that we have worked on, one in adaptation and one in mitigation. So the adaptation application is soil moisture estimation, and the broad kind of our initial goal was that we can use that to help inform irrigation planning, which can help you adapt to changing changing rainfall patterns because the water availability is variable, and if we can make it more effective in terms of distribution. That was the goal. We didn't end up doing that application, but we did end up doing some of the science work. So I'll talk about that. And the second one, which is the second half, is the mapping solar rooftop potential, which has a huge impact in terms of moving to clean energy, because a lot of the grids, including in India, are coal powered, and that's like the 25% of the energy generation climate bucket. So and both of these have a big imaging component, and I'll talk about those in the following slides. So just jumping on to soil moisture estimation. So what is soil moisture? I mean, there are different layers in the soil, as you can see on the left. There's a top soil. There is the root zone soil, which is actually where for crops, that's the region that matters. And this image is visualizing one of the public satellite products called SMAP. It's a passive radiometer satellite, very coarse, but it has pretty high accuracy. And in this particular technical problem, we were interested in just the top 0 to 5 centimeter range, because you can't really remote sense the one below. You can use hydrology models from there on, but if you can sense the top layer, you can do something about the estimate about the bottom layer. So we just focus on the technical problem of surface level soil moisture estimation. In all of these problems, I think ground truth data is most important for training, especially for machine learning, and validation even more so. So in this particular case, there is an international network of, in many countries, a network of soil moisture sensors, which is publicly available for research, called the ISMN. So we downloaded all the sensor data for many years from them, and that was the ground truth. And there's a lot of nuance here. I can't go into all the details, but it's only measures soil moisture at a point, but we are still estimating in a region. So there is always this discrepancy, which is hard to reconcile sometimes, but it's still something to work with. So we take those ground truth data, and we have these different satellites that we use as input. There's the RGB satellites called Sentinel, which is publicly available. We have the Sentinel-1, which is a microwave satellite, which is actually can penetrate the ground and see what's happening in the top 5 centimeter of the soil. We also use the DMs because the elevation affects soil moisture. We even use the soil type information available in this dataset called soil grids. And again, I won't go into the full technical details, but we combine them using convolution networks, and we regress to so the sensor is placed in the middle of these images. So we extract the data in such a way that the sensor is in the middle, and the satellite images are close in time to the sensor value. The sensor is doing a lot more dense readings than the satellites. So we do all of that engineering to create this data set. And then the machine learning is more straightforward these days. You set up a loss function and you train your models. And this is some work we published in a hydrology journal, which is kind of a new field for us as well. And I'll talk a little bit about the results. So quick overview here. So these 3 baselines are existing products using coarse satellites or hydrology land surface models. And we measure error using root mean square error or correlation. This is kind of what we have from the publicly available data sets. And what we do, and so there is some machine learning also here. So this is what we call the baseline. Like we just take these 2 products and add a small neural network on top of it. And then we have our satellite-only product, which is the last row, which achieves something close enough to the public products. But I think the value addition happened when we could combine the public product with these satellite imagings that we have and use machine learning to fuse those. That's why our paper was called a data fusion model, and we're able to achieve a lower RMSE and a much higher test correlation. Again, not enough time to go into all of what's the meaning and whether this is a meaningful change. But that's kind of the set of results. We didn't take this to the application side yet because this was not good enough. I think we had there were lots of things which was not usable right now. It was still remained as an academic research effort. The next one, which is much closer to production and productionization, is this solar potential mapping. And I'll discuss the technical problem and talk about the productionization later. So the technical problem is that we have the satellite images, which these days are 30 centimeters per pixel, taken from the side. They're not always top down. And we have optionally within Google, you can use multi-view geometry to build some coarse height maps. And from here, we want to go to a top-down view of the satellite image and a building height map. And we also want to understand the roof structures and the roof segments. And these are all inputs that solar installers can use to remotely look at a building and give you a quotation for your solar install. So this is the information they're looking for. And Google already has an existing product which does this, but it doesn't work on satellite imagery. It only works on very high resolution aerial imagery, where Google has commissioned flights, and they have extremely high resolution data. So our goal was to expand this to satellite imagery, and this enables global solar rooftop potential estimation. And I'll talk about how we are doing that now with this particular technical problem being solved. The first step in machine learning always is building the data set, and we build our data sets ourselves. In all of these problems, we sample everywhere where we have overlapping ground. So one of the things we need is ground truth, right? So we need to have a ground truth of this the DSM, and that we get from the other Google product, which has aerial imagery, and they've flown planes and they have a very high resolution 3D model of the world. So what we do is we intersect where we have satellite imagery and that imagery, and we find the location where there's intersection, and we download download the different types of images there. So this is a satellite image that we download. Sometimes we have this low coarse resolution 3D model available from satellite images, but it doesn't have the detail we need. We obviously have the aerial image, which Google has flown over, and we have this high resolution DSM, which is a ground truth variable. We also have some semantic labels. We have other models which can give us where is the building, where is the road, and we use that in our loss functions. And this is hidden behind the phone, but we get some other metadata as well, which is useful for training, and we get a data set about 1.1 million data points, of which we have a quarter we have this coarse DSM, and most of it we actually don't even have this input DSM. So we just have to estimate the height from the RGB image. But it's a pretty decent data size because each pixel is a training point, and this is not just the 1.1 million, but it's a pretty high resolution image as well. I won't go into the details of the model. It's just a visualization. It's what we do is we take the satellite image, optionally the DSM, so we can zero it out. So it's optional. We go through encoder decoder standard segmentation architecture, and we have different loss functions to estimate the height maps. So this is we have the ground truth DSM on the top right. We also have roof segment labels available to us on the I don't know if my mouse pointer is visible there, and then we have these different loss functions. So we're also writing this up in a paper, so you'll have a chance to read it when it's published. So again, fairly standard setup, but I think that the key is in the setting of the loss functions. We also mask out changes. There's lots of nuances because there's noisy data here, which we work on all these details to get it right. And after all of this, what we still get is a DSM which is oblique because we solved everything in satellite image space. And what installers need is a top-down view. So what we do is once you have a height map actually available for a satellite image, you can correct it to a top-down view given the satellite angle. So we correct that, but then you get occlusions in the image, and then we use a network to fill out those occlusions, again using the same training data but in a different projection space. So the setup is very similar. So I have, encoder decoder. I won't go into the details. And again, so we use two models back to back to kind of generate the final outputs that we want, and I'll show you how things look. So here is the RGB. This is the inputs to the model, and the right one is optional. I'm going to flip. This is the output that we're able to generate, and I'll flip between these two so you can see how we are correcting the heights of the buildings, and it's all orthographic, and you'll see a lot more detail show up on the DSM. Sorry, a lot more detail on the DSM. So the solar installers can actually use this now to place solar panels virtually, give you an estimate of solar potential, know the angle of your roof, so we know how much sunlight is falling. All those details that are available already in the Google product. Okay. So this slide has the other output. So we do a roof segmentation, so you know where all you can place panels in what surfaces, and the right side one is showing the potential of each roof segment based on the angle of the roof segment. So that's kind of the output overviews, and all of these images that I showed you are actually exposed via API. So solar installers actually call this API, and they can get building insights, they can get specific pixel-wise values of these things. Whatever is useful for them in kind of selling them to the customers. And again, I'm out of time right now, but we have these metrics that you measure for the building error, the angle of the roof segments, and how accurate are we getting the segmentation themselves. So there are all these metrics that we track at a country level. There's a lot of detail here. But yeah, that's all for my time. Thank you, and I'll see you in the question answers later. Bye-bye.
Hi, thank you, Varun, for this very engaging talk. So now we will move on to the question answering session. So so can I just request all the speakers to turn on their the videos so that we can have a truly interactive discussion. So the first question is for Tav. Tav, are you there?
Yes, Manjeera, can you hear me?
Yes, thank you. Yes, so So the first one is that by Swapnil Chaki. What type of CNN architectures did you use to recognize and predict when a child will be going into shock? But it also has the second part, and which I think is very interesting, that what kind of challenges have you faced in the training and evaluating with the models?
Thank you for that question. So when we built the models with the thermal imaging data, we did not have enough data to train deep learning models. So, initially we just used simple features like histograms of oriented gradients. And the key there was not the feature, as I said, that the key was actually domain understanding. So it was features fed into a longitudinal model that actually did the trick. So we built a mixed effects model, which actually looked at the longitudinal history of the evolution in these patients of shock. So it was I would say the study design that was more important than what architecture. And that's, I think, sometimes underappreciated as well. Regarding the second question, but as a follow-up to that, we have published with thermal videos using CNNs as well, and that was I think published in Frontiers of Physiology a couple of years back. But there we use videos, and that was a lot of data, so which we could build CNN models with. The second question was more about challenges in validating. So the first challenge in validating, prospectively validating, is, of course, I think making these models available in the clinical setting. So one of the things that we typically have found is that it's just one small step and easy to build a model, but getting the clinicians to actually review and build, and so we need to have built interactive applications in which, and that's one example also I showed, where clinicians can actually interact with the model. Second is explainability. Models will not be trusted if we just give it as a black box output. Clinicians want to understand why was this output given. Fortunately, in our case, it was a model that was actually grounded in domain understanding, that we know there's as high school, not high school, but first year medical school knowledge, that when hands and feet are cold and abdomen is warm, we should think about shock, because the blood gets diverted away from less important organs like skin, hand and feet to the more important organs like heart and brain. So it was easier to explain. So I think these are only two challenges that I've highlighted. There's many more challenges. A model that may work in one setting may not generalize to another setting. Also, a model that works in one setting at one point of time may not work well in the future because of something called concept drift. So the way we, for example, define shock, the way we define sepsis actually gets revised every year, right? And that's a big problem also in AI for healthcare, that our definitions also change. So the ground truth changes. So I think I've just highlighted some of these challenges, but data is obviously the biggest elephant in the room, that we need continuous data.
A continuity of data. Yes.
Correct.
Yes.
I'll pause it.
Yes. So we have another question for Tav, that as you have mentioned that for different medical conditions like cancer, antibiotic resistance, and COVID, how generative AI can help. So is there anything that can be done for thalassemia, because it is one of the prevalent diseases in the society which impacts lots of people?
I am sure, I'm not an expert in hematology, but I am absolutely sure that the genomics and side of community has already figured out what can be done. But thalassemia being a genetic disorder, I think early screening is very important. So for screening, thalassemia usually presents, as far as I remember from my medical school knowledge, usually presents early on in life and presents as fallen hemoglobin. But some forms of thalassemia are detected very late in life. So I think if we can target some of these screening initiatives for thalassemia, that will be very important. A more important thing may be actually to build machine learning models and that can actually indicate, pinpoint what mutations may be causing that particular thalassemia based on clinical data, based on history and so on. But as I said, I'm not an expert in hematology and I've not worked in thalassemia, but screening is diagnosis are some of these key things. Also, I think the role of AI in, for example, providing raising patient awareness. Awareness is a big part of screening as well. All these opportunities exist in this space of thalassemia.
Okay, yeah. Thank you, Tav, for this explanation. Next, I will move on to Varun. So, Varun, there is a question that the roof detection system that you have mentioned, how will it perform in case there are tree covers like in forest and in different states, and also in case of our country where there are different roofing materials and very congested setups. So,
Yeah. So on the tree cover, we haven't added this yet. I mean, yes, we do estimate the height of the tree. So that's one way. The tree, I mean, trees are important for calculating shading. So we do estimate the height of the trees nearby. So that helps. But I think if a tree is completely covering a roof, we right now do not interpolate the roof below it. We have some data. We haven't got to that. So there is some feature. The API was designed for the US and Europe right now, and I think we're working through some of the features that show up in other countries. So we'll probably add this, but that would be a segmentation thing, which we have some of the data labeled, and we do segment trees as well, but not in this, not exposed in the API. So that's the way we will tackle it. The roof materials and the other things, that's kind of the feature is we're waiting to see what the customer demand is. You know, we don't want to hypothesize some of these things. So yeah, some of these things we will add in over time. I mean, some of them might not be estimable, in which case, you know, site visits will be needed. So I think those will happen over time. So we're right now kind of trying to do experimental launch and actually see what installers give us feedback with. But those are kind of things we're aware of as potential things that will show up in the long run.
Okay. Thank you for that. So we'll move on next to the Shiv and Srini. So for the energy management, I have seen that you have a module on this carbon mapping. So is there, when this energy management framework, within that any kind of trade-off that we have recent interventions like carbon removal and things like that. So how to manage the emissions and also these mitigating the measures. So any kind of trade-off within that frameworks to advise that whether someone is to cut down their emission or go for this more carbon removal, this kind of intervention, keeping in mind the broader objective of whatever the particular industry or the entity that is working on.
I can make a few comments and I'll invite Srini also to add. So most of our work has been focused on operational problems, such as how to schedule a microgrid or how to, sort of facilitate trading across multiple markets, or how to schedule a set of distributed assets that may have some dependencies, like a network of dams, things like that. So we haven't focused on more, I would say, strategic or planning problems, which could also be posed as decision problems. But there's nothing to say that we cannot model that and put together some of those things, like the kind of problems you mentioned. But that said, that has not been a focus of us in the set of customers or context that we have operated in, right? So I just wanted to put that caveat. But yeah, I think decisions and decision management can occur both in the planning horizon as well as the operating horizon. Srini, you want to add any further?
Sure, I don't see Srini here.
Okay, no problem. Yeah, please carry on.
Hi, thank you, Shiv. So my next question is to Tirthankar on the accessibility part. So there is a panelist attendee question on like how we can have braille transliteration for music for person with visual impairment. And I think although there are some like we can transliterate the musical notations, but any idea like how it can be made accessible based on the specific requirement for the persons with visual impairment, like writing or editing or making modifications on that. Deepthankar, are you there?
We cannot hear you, Tirthankar.
I believe for the interest of time, let me move on to a different question. So it's from the panel for Varun. So, did you use any process-based models for the soil moisture, the work? And the second question is that there are some data-rich and many data-poor regions, and is there any scope for transfer learning for fine-tuning the models for the data-poor region? And if yes,
Yeah. Should I answer, Manjira, or so
yes.
Yeah, fine. Oh yeah, I think I answered a little bit on that. So we did not use any process-based models. I think we did read some of these things, but the process-based models are, I mean, first of all, using output of another model to train and validate another model was always confusing. A lot of people do that in the geoscience community. It's very confusing because then how can that model get better than like, so I think we didn't use it. Also, the process-based models have lots of errors. So we did want to use as close to ground truth. I mean, there's always a level of ground truth. I think even the sensors have issues and they only measure very localized thing. But I think in this case, we wanted to have pristine ground truth. So, I mean, and there was a big enough data asset available. Transfer learning, we didn't get to doing it. I think because we decided to move on to something. There is possibility. I think it will make sense because we have covariates. First of all, because it's satellite imagery, so you are seeing some characteristics of the region. Whether it would work or not would have to be an empirical thing. Our plan, or if this would have worked well enough, I think it worked well enough for our academic publication. But I think we decided to switch gears. We would acquire some ground truth data to see how well the transfer learning and just first of all deploy and see. We didn't get to doing it, so I don't know how well it works, but I think that is obviously one way to scale from data rich to data poor. But I don't think this was good enough for data rich region as well to be actually used in practice. That was what we decided, and so we just moved on from there on.
Yeah, thanks, Varun. Yes. So, Tirthankar,
Yeah, am I audible now?
yes.
Yeah. So thank you for the question. So essentially, transliteration of music to braille has got two different aspects. One is transliteration of musical text to braille, and another is musical notation system, transliteration of notation systems to braille. Uh, Although this musical text to braille transliteration is to some extent solvable problem, but transliteration of, I mean, many of the present works are where people are working on transliterating Indian language, musical notation systems to Braille, which is a complex task because we need to, define these notation systems. Corresponding data sets have to be created for the transliteration purposes, and then this transliteration has to be carried forward. And there are, although for Western musical notations and Indian classical musical notations are quite different. So we are presently working on designing a tool for transliterating Indian classical notation systems to Braille.
Thanks, Tirthankar. So, in the interest of time, we will not be taking any more questions in this session. So, the speakers can also engage in the question answer chat, and we have a networking session at 12:30. So, I request all the speakers to join if you are available, and we can do more discussions at that. So, thank you, and over to other.
Thank you, Manjira, and thank you to all the speakers, Srinivasan, Tavpritesh, Tirthankar, and Varun, for your excellent talks and the insights that you shared and with the questions and answers. So with that, we move on to the next item of our today's agenda. So this is going to be a panel discussion, but the topic is going to be navigating the data science landscape in India, career opportunities across sectors. So this session will be chaired by Lavanya. Lavanya, over to you.
Thank you, Adway, and welcome everyone to the panel. We are thrilled to have eminent panelists today across various sectors, moderated by Dr. Preethi Jyothi. So we have panelists Dr. Alpan Raval, Deepthi Nandakumar, Dipyaman Banerjee, and Dr. Subhashis Banerjee. Here are a few words about our panelists. So Dr. Alpan Raval is the Chief Scientist AIML at the Wadhwani Institute for Artificial Intelligence. He is a theoretical physicist by training with a PhD from the University of Maryland and an undergraduate degree from IIT Kanpur. His research background spans theoretical physics, computational biology, applied mathematics, and machine learning. He previously led applied AI teams at LinkedIn and Amazon and worked as a researcher at DE Shaw Research. And earlier on, he also taught mathematics and computational biology as a tenured faculty member at the Claremont Colleges in California. He co-authored a book, Introduction to Biological Networks, and over the last 24 years, he has applied machine learning to problems in computational biology, chemistry, queuing, computational advertising, online newsfeed optimization, content moderation, public health, agriculture, and many other fields. Our next panelist, welcome Alpan. Our next panelist is Deepthi Nandakumar. She leads the
Thank you.
AI organization at GE Healthcare, developing industry-leading algorithms and platform capabilities for the healthcare domain. Previously, she worked on advanced sensor RFID and vision algorithms for cashierless checkout offering at Amazon AWS, as well as leading efforts around advanced compression and streaming technology at Amazon Prime Video. Prior to Amazon, she led the engineering and development of the world's most widely used open source HEVC encoder, X265, designing and optimizing for performance and encoding efficiency. She has several patents, a master's degree from the University of Illinois Urbana-Champaign, and a bachelor's degree from NIT Calicut. Welcome, Deepthi. We also have Dipyaman Banerjee, who's the CEO of the National AI Innovation Hub at IIT Kharagpur, and who's recently worked with several startups. He is an AI leader and a scientist with 20 plus years of experience in AI research and application of AI across multiple industries such as telco, financial services, food delivery, retail, and ad tech. Before joining the IIT Kharagpur Innovation Hub, Dipyaman worked at IBM Research for 11 years across various tech domains, including cyber physical systems, optimization, cloud technologies, IoT, and others. He has also served as the head of data science in Airtel and a principal data scientist in Swiggy. Dipyaman is a prolific author and inventor with many published papers and granted patents. He's also a senior member of IEEE. Welcome, Dipyaman. We also have Dr. Subhashis Banerjee from the Department of Computer Science and Engineering at IIT Delhi. He was also with the Ashoka University between 2021 and 23. At IIT Delhi, he has held the Ministry of Urban Development, Microsoft, and Nareen Gupta chair professorships. He was also the head of the CSE department and head of the Computer Services Center in the past, and played a key role in developing the supercomputer infrastructure at IIT Delhi, which is one of the largest in the country. He is also associated with the School of Public Policy and the Center for Transportation Research and Injury Prevention at IIT Delhi. His primary research areas are computer vision and machine learning, with special emphasis on geometric algorithms, with recent interest in policy issues, digitalization, and society. Dr. Subhashis graduated in electrical engineering from Jadavpur University and did his master's and PhD from IISc. Welcome, Dr. Subhashis. We are thrilled to have you. Now, finally, our moderator is Dr. Preethi Jyothi. She's an associate professor in the Department of Computer Science and Engineering at IIT Bombay. Her research interests are broadly in machine learning applied to speech and language, specifically focusing on Indian languages and low resource settings. Her recent awards include an Amazon Research Award in 2022 and an Outstanding Paper Award at ACL 2023. She received her BTech from NIT Calicut in 2006 with a gold medal in computer science and her MS and PhD from Ohio State University in 2013. Subsequently, she was a Beckman postdoctoral fellow at the University of Illinois at Urbana-Champaign from 2013 to 16 before joining IIT Bombay. Welcome once again, Preethi.
Thanks,
Looking forward to a very insightful discussion. Over to you, Preethi.
Thank you. Thanks, Lavanya. Welcome again to all the attendees and our esteemed panelists. Thanks once again for joining this panel. So without further ado, I'll kickstart the panel discussion with a common question that we'll pose to each panelist to answer. So the question is, if you can tell us a little about your educational professional background and how you think that prepared you for your current career. And a related question is, what do you think are kind of the skills needed for a career in data science, which are specific to your current sector? And if you could also comment on the opportunities and challenges that you see in your sector. So maybe we can go backwards and start with Professor Subhashis.
You put me in a spot. Yeah, so I am the academic. In my PhD, I use reinforcement learning for computer vision problems. And I gave it up soon after PhD because it didn't work that well in those days. It was 35 years back. And I think that I did my early professional career in a day where machine learning was a bad word. Right, most things didn't work. And so I worked on computer vision, mainly on geometric techniques, but throughout my career, I've dabbled in data science and machine learning. So it's on and off. Though it's not a mainstream research topic ever, but I've always worked on it to some aspect or the other. And I'm now full-time with Ashoka, so no longer with IIT Delhi. So that's a correction. Regarding what is necessary to be a data scientist in a sector, I'll start with a word of caution that, when I look at students, I see that there's too much of Python coding and end-to-end learning, putting a system together somehow, and measuring accuracies on data sets. That seems to be a common approach. Add Ashoka, and among all the youngsters. So I cannot overemphasize the fundamentals, right? Fundamentals in computer science, data structures, complexity theory, algorithms, and statistics, right? And also domain knowledge. I think that when you heard Varun Gulshan, you heard Tavpritesh, Sethi just a while back. So a lot of the stuff that can be done with data or cannot be done with data, the insight can only come from deep domain expertise. Data is a thing that is easy to go wrong with. And data can never override the fundamental understanding, right? So if you get something from the data that contradicts your native understanding of a topic, you should be worried about it all the time. And there are also a lot of misuses of data that happen. So once you look at a data, one requires domain knowledge and intuitive computer science understanding to figure out what the data can do and what it cannot do. What is the kind of information that is available in the data and what's not available in the data? What are the kind of things that you can never do from that set of data? And one of the most important mistakes is causality. So we gave a Turing Award to show that causal inference is not possible from observational data in 2011. But you see papers, you see results, claims, both in academia and in popular media, where you came, causal inference from observational data. So it's sort of elementary statistics that there can be multiple joint probability distributions that can give you the same observation, same marginal distribution over the observation in the same data. So which interpretation that have you got from the data requires unraveling, requires intuition. And this is not only true for inference, but also true for predictive analytics. So when you're doing prediction, there are issues of reliability, there are issues of bias variance trade-off, overfitting often in a data set. So those requires deep ground level understanding. And the last bit that I'll emphasize on the basic training is ethics, that when you're doing an inference or when you're doing a predictive analytics, to whom you're applying it to, what kind of consequences that kind of data analytics will have. So societal and a political understanding is also sort of crucial. So opportunities, you heard in the previous channel, there are opportunities in climate change, sustainability, healthcare, informatics, epidemiology, public health, so data science is coming a big way and machine learning is also coming a big way. And so one needs to be prepared, theoretically sound, and need the practical skills as well. Yes, I'll stop here for now.
Thank you so much. Yeah, the lot touched on lots of fundamental points, to reuse your word. Maybe we can have Dipyaman Banerjee, if we could request you to address this question.
Sure. First of all, thank you, Preethi, and thank you, the organizers. And very good morning, good afternoon to my, good evening, wherever you are, to my fellow panelists. Right. So I'm Dipyaman Banerjee. My career, if I look at it, I think I can sort of separate it out in three parts. First part is the IBM research part, where I was for 11 years. I worked as a researcher in IBM research, working on doing patents, publications, working on fundamental problems. Uh, the second part is where I sort of joined the industry and startup area like Swiggy and Airtel, where I'm more on the application side, where I'm taking those research and trying to apply it to real world problems to make real world impact. And the third part is now where I'm in an academic setting, trying to sort of bridge the academic research with industry and with government initiatives. So these are three parts, and I think all of these sort of led to where I am today. I'll just start with the IBM research part, I think, and what it gave me. So 11 years in research, I think if I have to point out two basic things that I gained from there, are one is that sort of ability to abstract out a problem. So the ability to abstraction is, I think, what you learn in a research lab, and how to sort of try to see the bigger picture and try to make the problem as big and trying to have it impact footprint as big as possible. On the other side, the second thing that I think it also helps you to how to break down complex problems. I think one of our senior leader once said that if you know how to break down complex problems, I think you probably can solve most of the problems that are thrown at you. So that is something you learn. Whereas as you move to the, say, more on the business side of things, or industry side or startup side of things, when I moved to Swiggy, one of the realization that I had is that it is a much faster game, right? So I have to move much faster than I used to in IBM research, because here the time is of essence. You obviously have to have a lot of here and now problems which you need to attack and impact, applying the knowledge that you have. So while taking what I have learned from IBM research, I was able to sort of adapt sort of quickly to see that how I can take a business problem and then I can map it to a data science problem. I think that is one of the key skills that you learn in when you are working in an industry where you are applying data science, right? So, and that is not, and that is easier, that is harder than it sounds, right? So business problems can be very ambiguous. Business problems may not be as specific as a given research problem can also be ambiguous, but their contour is much more hazy in case of business. So you have to sort of start with the business metric and map them with your data science metric. That is something you need to learn, and also to see that probably you don't need to solve all aspects of the business problem at the same time, and trying to prioritize which one you want to solve first while talking to the different stakeholders. And there, I think communication becomes one of the key skills that you sort of acquire in a business domain, because when you are talking to your stakeholders, who would be typically either business managers or product managers, or maybe even engineering folks, they do not speak the language of data science, right? So you have to sort of find a way that how you can take a complex concept like graph ML and then help you to understand your business counterpart, and help them convince that applying this technology can actually benefit their ultimate business metric that they're trying to move, right? So that is something I think that you learn. In my third stint where I am now, it is again a whole different problem, because here I am sort of trying to bridge the academic research work with the industry and ministry. And while my experience from the previous two avatars definitely helped me. But here I also have to sort of understand the academic setting and how research is done there, and what are the levers that I can pull to make the academic research actually see the light of the day, and can make these collaborations with ministry or with industry. So that is, this collaboration part is something I think I'm working on currently, and still it's a learning journey that I'm going through. Challenges in terms of, I think, and as Professor Subhashis Banerjee was saying, that yes, I think I will agree that fundamentals is definitely something a data science should focus on. To add, I would say that also try to figure out, if you are looking to work in a startup or in an industry, try to figure out that what is that business metric that you are trying to move. And if you can figure that out, and how does your data science actually impacts those business metrics, if you can figure out that relationship, that would help you to succeed in a startup and industry quite a bit. Challenges with the industry and startup is that data is not very clean. So the data won't be clean. You won't get the ground truth. You will not get all your positives and negative classes, and the data will be imbalanced. So these are some of the things you probably will not always encounter in a controlled space when you are working in a laboratory. But when you are actually working on something that say that tries to cater to a people of say 15 million or 20 million customers, then the variety, velocity, volume of the data is at a very different scale, and you have to build something that sort of can work in that scale. So that is something, scalable solution is something you need to build. And you also understand that other than just the data science modeling, the fun part, as we say, you also have to learn the grind work, the tough part, which is not so much fun. For example, data cleaning, feature engineering, ML ops, right? Data engineering at some level. You also have to learn all those skills as well. So, and then probably you will be at a point where you, as a data scientist, you can make the impact which the business will appreciate, or where you will be able to actually make an impact, a real business impact, right? So that is something I would say would be one of the greatest challenges that one has to overcome as they start their data science journey. So I will stop here.
Thank you so much, for this very kind of important applied perspective. I think I'll request Deepthi now to just weigh in on this question.
Absolutely. Thanks so much, Preethi, for the question, and thank you to the IKDD committee for inviting me here. This is my first time, so it's been a great session, even listening to the previous talks as well. So thank you so much. So yeah, I started, when I finished engineering, and incidentally, Preethi and I are from the same college and the same batch as well. So when I finished engineering, signal processing was a sort of topic of choice, and to Dr. Subhashis' point about getting those fundamentals, that was sort of the algorithms that anchored me as I started my career. So a lot of work on signal processing, and the application of that was most importantly felt in audio and video encoding, right? So especially as I left grad school, over-the-top video streaming was not at all popular. In 2011, Netflix was just starting up, and certainly Prime Video was not there in some earlier avatar or so. YouTube existed for very short formats. So that was a very interesting time for me to get into video streaming and video compression in particular. And all the basic signal processing algorithms that we learn in undergrad and grad school, etc., were applied practically to solve the whole challenge of video streaming and video compression. So it was a very exciting time in that field. And for the first 5 years after grad school, I joined a startup that was, my grad school advisor was the CTO, and we developed a bunch of open source technology, incidentally, that to this day is still very widely used and is one of the most popular softwares in its category. That was a very interesting exposure to the whole business of video streaming and video compression. Then I moved into Amazon Prime Video, which obviously took over the top streaming to a next level, right? Across the global, at global scale. How do you stream? How do you store millions of titles of premium content, and stream that to customers that are spread across? So the whole challenge, of taking taking your algorithms and applying it at scale, so solving critical problems such as unstable network bandwidths, etc. A lot of us use a lot of online video today, and today we rarely see spinners and buffers, but they used to be pretty much standard in the early days of of video streaming on the public internet. So those were sort of the challenges that I started with. And I spent over 8 years in Amazon, 5 years at Prime Video, and I think this was it was a very good time to be in that domain as this expanded globally as well. And after that, around 2020 or 2021, I was obviously reading about, we had already launched deep learning models in the video streaming and video compression world. But there, the objective was very straightforward. You wanted to use deep learning to reduce the size of your files, to preserve quality, but rarely to modify the video itself, right? The goal is to preserve the artistic content of these high value titles. So we had deployed a lot of deep learning models for artifact detection, artifact suppression, content adaptive encoding, adaptive streaming to combat fluctuations in the network, and so on. But around 2020, 2021, I was seeing the whole domain of video understanding open up. So how do you understand the content of the video and draw conclusions and map it to the real world? So that was a very interesting field to explore. And I sort of moved into another team at Amazon that was working on cashierless checkout offerings in physical stores. So that was, again, as complex architectures like transformers were coming of age, we were able to actually use different sensors. There are load cell sensors that detect weight changes. There are RFID signals. There's of course vision and camera. And so these modern architectures, sort of helped us fuse these different signals together to generate a real world prediction, right? Somebody took something or somebody returned something, and therefore you should be charged to the credit card, etc. So that was again a very a big learning experience, and lots of impact in terms of the business, the underlying business itself. I like to look back at my time at Amazon, where hey, machine learning was really maturing as production systems. So you get a lot of training in terms of how to think about machine learning problems. And to Dipyaman's point about translating from the business metric to a data science problem, so that's a lot of training that comes in, especially companies like Amazon and Google, because the immediately monetizable areas are in ads prediction, sponsored ads, click-through prediction, etc., right? So there's a lot of very robust training that we get in terms of how to think about data science, how to deploy it, how to monitor these solutions at production scale, right, at million or billion scale. So that was very valuable stuff. And then, around 3 months ago, I moved into a very different setting at GE Healthcare. So I lead the India AI team in Bangalore. And, it doesn't get any more real world than this, because you are actually in there in a clinician setting, right? In a clinical setting with a clinician, facing a patient, and the tools that you make literally drive the conversation. They drive the proposed treatments. They, you can, there's a whole spectrum of opportunity in terms of where AI can leverage, can change the healthcare model existing today across different countries, across different settings, right? So in that sense, I think from a career perspective, I've mostly been driven by, an opportunity for impact and an opportunity for impact at scale. And the latest ones, especially with large language models, etc., they've matured to a large extent so that it can be applied in the clinical setting with a lot of efficacy. So this it's also a turning point, I think, in a very critical domain like healthcare, where this can scale with lot of impact. In terms of those who are starting for a data science career, I think there's a wide spectrum of opportunity to choose from, right? Today, for a specific problem, for a specific solution, it's very easy to get to the 80% stage. The foundational models are available, etc. You don't even need a data set in many cases. If you decide that you don't want to, fine tune or align or anything, it's very easy to get to the 80% stage. But there's a whole world of difference between that 80% and to something that can actually go out into production. So, from a data science perspective, I would say, hey, be very conscious about what you want to, about the kind of work that you want to do. Teams that are doing foundational, research, foundational training work are fewer in number, as they should be, because there are very specific situations that require it, right? So they are fewer in number. So if that's what you want, go for it. If you are very interested in applications or in impacting the real world in applications that can change the landscape, then be very intentional about joining those kinds of teams. And there's a whole world of difference between getting from that first POC, right, to something that exists, that can actually be launched in production. And the big difference there is also that whole bridge between science and engineering. So as a data scientist, prescribing your work in very limited fashion, saying, okay, this is what I will do, this is the model I'll develop, etc., is generally a recipe for failure. So be very mindful about the fact that you have end-to-end ownership of your product, and that will include some engineering, that will include some give and take with engineering as well. That's the only way your products can actually, your solution can actually make it out there as a product for the business. So, being very mindful of what you want to, work on, that would be good. And from a personal standpoint, and this is not unique to data science, but, also, having the opportunity to move from a, deep individual contributor role where you have time to read up, where you have time to actively work hands-on on solutions, into more leadership roles and back and forth. I've done that a couple of times, right? Depending on the domain I'm in. I think that also, gives you an idea in terms of how you want to grow your career as well. So these are all opportunities that, as folks who are entering the data science world, you have in front of you. You can choose and be intentional about where you want to go with it.
Thank you so much, Deepthi, for that very kind of valuable look at all your experiences in the different specialized domains and things to be mindful of. So with that, last but not the least, Alpan, if I could request you to address this question.
Thank you, Preethi, and thank you for inviting me to be a panelist here. The challenge of going last is having to be careful of not repeating what was already said, and especially when one agrees with everything that's been said. So I will try and be careful, echo most of the remarks that have been made already. So my own journey has been somewhat checkered. It's not a journey I recommend for everybody, but it turned out to be, I think, reasonably appropriate for doing applied machine learning. I started out as a theoretical physicist working on problems in quantum gravity. It's as far away as you can imagine from what I'm doing today. Used to correspond on various problems with Stephen Hawking back in the day, and then I changed fields to computational biology around the time when genomics was becoming a big deal. So this is just around the time the Human Genome Project took off. There were very interesting fellowships for people to transition from the quantitative sciences into biology. And I found the whole thing very, very exciting and decided to take the plunge. And so I started a postdoc in computational biology. And one of the first problems assigned to me as a postdoc was, can you, here is some data, can you do protein structure prediction with it? And I said, how do you do this? I was only used to the tools of, applied mathematics, theoretical physics, done some coding, very little. I said, how do you do this? So my postdoc advisor said, use machine learning. So I said, what's machine learning? And he said, well, there's this person at University College London who runs a small group there. You can go and talk to him, spend some time there. His name is Geoffrey Hinton. And maybe you can spend some time with his group and learn a few things about machine learning. So I said, great. And of course, I didn't know who this person was. He wasn't very well known at the time. I ended up working with him for, I think it was a couple of months. Hinton, this is before the days of backprop, when backprop was sort of rediscovered by Hinton and his team. And he told me very bluntly that neural networks don't work. I've worked, I've spent my entire life on neural networks, but they don't really work. And so you'd be much better off working in the area of Bayesian networks. So I ended up working with Zubin Garamani, who was part of his group at the time, and we used Bayesian networks to do very basic protein structure prediction. It wasn't even detailed it wasn't AlphaFold type of structure prediction at all. It was just sort of classifying proteins into various structural classes. But that itself was a challenging problem at the time, and we used Bayesian nets to do this. So that's how I got started in ML. And so I've been doing, applied machine learning in one form or the other ever since. And I think in terms of the kinds of backgrounds that students should have, it's interesting. So I agree with Subhashis. There's been a lot of emphasis on sort of downloading code from GitHub and fine-tuning it for your data set, but not enough emphasis on fundamentals. And I think you just can't overemphasize fundamentals. I think that the whole field has become very interdisciplinary. It was always interdisciplinary to begin with. A lot of the ideas, in fact, came from physics, and that's what that's stood me in good stead. A lot of the original ideas behind neural nets came from trying to solve for partition functions of Ising models, and even some of the ideas today, like diffusion, and in fact, variational principles came from statistical physics. Diffusion models are inspired by statistical physics models, although typically you don't sort of go in this time reversed way, starting from randomness, but they were certainly inspired by non-equilibrium statistical physics models. And then more recently, a lot of attempts to understand how neural nets actually work use dynamical systems theory, which also comes from physics. So I think it's very, no matter what you specialize in, I think there's a number of entry points into machine learning, computer science, mathematics, statistics, physics, and so on, electrical engineering. Pretty much any of these very quantitative fields can prepare you for machine learning. But I think it's very important that whatever you do, you sort of go deep into things and do it well. I'm actually a bit worried about recent programs in that that award degrees BTechs in data science and machine learning to begin with, because I'm not sure. I mean, they may be doing it, but I'm not sure that you get sort of fundamental and deep into a single field. I think it's very important that you do that first, and then look at connections with other fields, because that is what will prepare you to look at these connections in a meaningful and intelligent manner. So I think it's very important to get into a field that's mathematical, that's quantitative, get into it in a very deep and rigorous manner for your undergraduate education. And then once you graduate, you can get into sort of other fields, you can explore linkages to other areas and so on. I think that is what really works best. Now, as far as challenges and opportunities go, I think all of us know that the opportunities are huge, especially now with language models sort of proliferating and these multimodal models solving very complex problems and so on. There's lots and lots of opportunities, both in business, in research, as well as in the work that we do, which is in the social sector. And I think there's lots of interesting opportunities in the work we do, and there's not enough people doing it. And I can talk a little bit more in a follow-up question. But the challenges are, especially in the work we do, there's the standard challenge which everyone's talked about, which is the data challenge. And in the work we do, there's various challenges related to data. Data is not, we have the small data problem. We don't have the big data problem, right? Because there's very limited data in the social sector. There's very limited high quality data. It needs to be curated. So you need to develop skills to understand data, to not just throw it at an algorithm, but actually to curate, to understand, to throw out data that isn't meaningful, that may be noisy. So the data challenge is huge. And the second challenge that we have is really the other end, which is the deployment and scaling challenge. Especially, again, I'm talking specifically for the social and development sector, very hard to get AI adopted on the ground. We've had challenges with our solutions. Most of the time goes in collecting data, and then once models are ready and tested, getting them deployed and scaled. So just as an example, one of the projects that we are working on is trying to estimate baby weight in rural areas with video. And so this is not a high-res video. It's a video taken on a basic smartphone that's given to ASHA workers on the ground. And it took us I think more than 5 years of data collection in the field, to actually get to enough samples to make a decent model that's robust enough. So that's really the type of intensive data collection exercises that we have to go through. And then getting this used, deployed, building trust is a huge challenge. And so I think the challenge of responsible AI is not just the challenge of making existing AI systems responsible, but I think it's also the challenge of using AI in a responsible manner. So these are some of the issues that come up. I'll pause here. Thank you.
Thank you so much, Alpan, for that very inspiring kind of look at your journey, and also this important message that you can come from different backgrounds, and the barrier of entry into data science is not very large as long as you have rigor and you go deep into the fundamentals. Great. So I think in the interest of time, we would love to hear more from our panelists, but I want to leave a little time for questions from the attendees. I'll do another very quick round across the panel. If I could request you to give kind of maybe quick answers. So the first question is to Professor Subhashis. So with your current stint at Ashoka University, could you give us some insights on how data science informs governmental policy, and to what extents do central and state governments of India work with data scientists for policy regulations?
So I can't say that I'm fully aware of this, but at Ashoka, we host 2 data repositories currently, and they are the Center for Economic Data Analysis, and this is roughly all the data that Government of India has ever published in the last 70 years. in a curated, accessible way. So they are, they're available from the government departments also, but not as easily as they are from Ashoka. And we also have a Center for Political Data, which is all election data for the last 70 years and last 20 years, even panchayat level election data. So if you want to do political science work, data-driven political science work, then Ashoka is your go-to place. And so I would say that in government, these are the two data sets that are most used. I think economics is the biggest use, and it's not only government players that use economics, mostly visualization, but some regression, very little machine learning, I would say, as of now. But there are NGOs, there are academics, there are policymakers, journalists. So census, NSSO, public finance data, the debt data, the National Family Health Survey. So there's a huge amount of policy formulation that uses those kind of economic data. Political data uses a little less. It is more to influence elections and stuff of that kind. But I think that in future, modern economics cannot ignore political data. So when you're analyzing a region, the politics of the region and will become very, very, very important. We are feeling a need to overlay the political data and the economic data on a common knowledge graph and overlay it with GIS and satellite data. And the only way to overlay the two is with GIS. And so we are building a GIS layer. And there's a lot of demand from the government, from various sectors, to put a GIS layer and put satellite data to do kind of thing that Varun Gulshan talked about a little while back. Also overlay, so we have got a Center for Climate Change and Sustainability. That's a very highly talked about center, and it's the elephant in the room. The climate change, both the determinants and the policy response are not very well understood and a little chaotic out there. So I'm sure there's a lot of action in that area. From groups like Alpans, they are into also big time into agriculture and other social problems. So I see, the pollution is a related issue, but I think the determinants of pollution are well understood, and whatever is the attribution to the pollution, the policy angle is easy. Just cut down the emission from wherever you can. So, but yes, there are lots and lots of researchers that engage with us for pollution data, a variety of kind. IIT Delhi is building in Sonipat one of the largest pollution pollution data centers, which is in collaboration with Ashoka, right next door. Public health and healthcare, we have a Center for Digital Health, like you have at IIT Bombay. And I think public health and epidemiology, I think you heard of that problem of AMR, antimicrobial resistance, and I think that's a killer. I mean, in healthcare, if there's one single important problem, it is AMR, and how to stop it, how to prevent its spread, what exactly is the level of AMR resistance and penetration. So these are problems that are very, very important to understand. And I think that in public health, data-driven public health, we saw a lot of interventions during COVID. I would say chaotic interventions, not the ones that I would recommend going about in a way. Most were wrong than right. But there was a lesson. There's a lesson in those interventions, right? And that to understand any time a public health issue crops up like this, and we have long-term public health issues like tuberculosis. It's a sort of an endemic disease in India. That's a biggest killer. And to understand those, you require public health epidemiology in a big way. And these subjects are still developing. COVID taught us that they're easy to go wrong than right with this kind of analysis. So I think there's a lot of possibilities that I see in the government sector.
Thank you.
Maybe
Yeah,
we can add
thanks so
on
much.
later.
Thanks a lot. So, Dipyaman, given your kind of deep experience in industry and currently your engagement with startups, what kinds of data science problems do you think are currently very exciting for Indian startups to pick up? And where do you think there's kind of most room for growth, and where kind of data science, new data scientists can engage?
Sure, sure. Uh, I think what I'm seeing is a very, very fast acceleration happening in the space of Gen AI and LLM, right? So that is definitely one area. I mean, I think there's for everyone to see that people are actually, the opportunities there are increasing every day. I was reading somewhere that 65% of the jobs are going to be in these areas where you are sort of required to learn how to apply LLMs in your particular domain. So definitely, and given the linguistic diversity of India, I think most of the companies I know in Airtel, we did build one to actually build customer support systems in various languages to support different Indic languages. Preethi, amazing work being done at IIT Bombay. You yourself are working in some of these areas. Most of them, not only at many other companies, specifically in the space of customer support and content generation, people are trying to apply LLMs and Gen AI a lot. So that is definitely a skill which you might want to have in your pocket, and that can take you open doors for you. So that's one thing. Another part that I'm seeing is AI in agriculture, and Alpan, you are very closely working in that area, I know, with Wadhwani AI. So and that is also I'm seeing in IIT Kharagpur, in other institutes also. In IIT Kharagpur, we have a specific agricultural engineering department and food engineering department, and we collaborate a lot with them. So in agriculture, we are seeing, be it precision farming, trying to increase crop yield, trying to have smart irrigation systems, and coupled with geospatial technologies like remote sensings. So trying to figure out, do weather predictions. So a lot of good things are happening in AI in agriculture, and we are an agriculture first country. So that is another space. But yes, I think important thing there is to also have your domain expertise, or to pair with a team which has the domain expertise. So unless that is done, I don't think you can actually deliver the impact ultimately to the ground. So, and one of the actually, I listened to multiple podcasts on this, and most of the people who are working with agricultural farming, they were saying that it is the last mile part where you are trying to take the technology and then sort of trying to help the farmers to use it. That's where most of the challenge lies, because the trust has to be built inside the farmers for them to trust these technologies so that they can apply it. So you can have all the best of the technologies, but they might not use it, right? So that is something I think is important to understand. The other space I see is obviously healthcare. As Professor Banerjee was also saying, there is a huge lot of things that we can do in terms of healthcare. Data is obviously a problem there, but I think still, if we can build data science technologies that can help giving healthcare to our marginalized populations which do not have access to greatest of healthcare technologies. If there is a way to sort of give it to them, that would be extremely good. And I think people are actually trying to look into those problems. They're becoming serious to see that, trying to build. So I know that there are many of the translational projects that we have funded in IIT Kharagpur and in other sister universities and institutions in the AI and healthcare are actually trying to build portable instrument for detecting and localizing healthcare problems in patients, which can be done remotely, which can be where I can send that particular device and can get the data remotely, right? So cheaper portable solutions is something that we are trying to devise. So healthcare is another space. The third thing, which is close to my heart because I did my master's on it, is I think I would say, and this is a bit nascent stage, but I think uh, this is another area where people can actually try to look into and can probably see some traction. I believe see some traction in the next few years is multi-agent AI, right? So where we are actually trying to see different agentic algorithms or agents, artificial intelligent agents, where they can actually collaborate and can do work together. So that is another space. It's still a bit researchy. There is active research going on. But I think that is another space. People who are interested in doing more fundamental research in the data science space can look into that. Uh, I think these few obviously comes from top of the mind. I, other areas like manufacturing, transportation, obviously there are many scopes to apply AI in all those areas as well. But as I said, that the domain knowledge would be of highly importance there, and you probably need to have that or partner with somebody who has that. So most of the startups we are seeing that they are doing good, and also there is a big thrust from the government as well, is to have deep tech AI, right? So most of the startups, so we are doing good in startups in general, but deep tech startups are quite few in numbers in our country, and we want that to scale up. So deep tech startups, any say in this area of space or underwater or quantum, I mean, those areas, I would, if anybody who has an entrepreneurial bug inside them, so probably deep tech startup is something they might want to look into.
Thanks so much, Dipyaman. Just a quick note to the attendees, we will take your questions. I think it might go a bit beyond time, so please stay on the session so we can take your questions towards the end. So Deepthi, this has come up multiple times, which is that data science is interdisciplinary. So how do you think, what are the trade-offs involved? How should candidates prepare for such kind of interdisciplinary fields? And do you think there's a stronger need for specialization today compared to a few years back?
Yeah, I think that's very interesting. Around 5 years ago, there were certainly silos, right? Even in the machine learning, deep learning field, computer vision was one. Language processing was one. But very soon, I think, once some of these foundational architectures like transformers, etc., came in, there's been some level of convergence there in terms of the actual tool sets and skill sets that data scientists bring. So both vision as well as language to large extents share backbones, and even large models like GPT-4 and that entire class, they are multimodal by default. So there's been a fair amount of convergence in terms of skill sets, etc. They're not quite so siloed as they used to be 5 years ago. That's from a skill set perspective that data scientists bring. So I'm seeing a lot of cases where data scientists can move easily between these domains and modalities with a fair amount of ease: time series data, vision, language, all of that, right? So that's been a welcome change, I think, because now there's also better cross-pollination of techniques across these domains. I think to your point about interdisciplinary domains, I think you also meant domains like healthcare, agriculture, climate, etc., right? So that is one place that has been echoed, I think, by previous by Dr. Subhashis before. Dipyaman also mentioned it earlier. One thing that I would definitely caution is that while we think of data science as this core skill set to solve problems, that deep domain knowledge, of the specific business problem that you're trying to solve, there's no way you can replicate that deep domain knowledge without the grind and the rigor that you put in. And I speak as somebody who very recently, made a big jump in domain as well, from Amazon to healthcare, and so the rigor that goes into building that domain knowledge simply cannot be underestimated. And I think that's something that I would caution all entering data scientists to be very, very aware of. And that's simply because you are not getting a nice, well-prepared data set, right? You have to deeply understand where the data comes from, the mechanics of generating that data. That will 100% affect how you design your solution. right? You have to deeply understand where your solution is going to be deployed, in terms of, the problem that it is solving, the persona that it is targeted for, especially in a field like healthcare. There are many different personas. You can have solutions tailored for the doctor. You can have one tailored for the nurse or technician, for the hospital administrator, for the patient. And these are all very, very different solutions in terms of risk as well as impact, and so on. So, like that is one place that data scientists, I think, that we should be careful never to underestimate that deep domain knowledge. And in corporate speak, I would put it as, make your product manager your best friend, right? Because, coming from that, as tempting as it is to dive into the details of the how you want to solve your problem, you have to very deeply understand the what and the why as well, right? Because otherwise, your solution will not translate into the real world. So that deep domain knowledge, there's no way to accelerate it. You have to go through the rigor and grind, and that's also one reason why I think very frequent switching of domains sort of makes that harder to build the depth that is required for a given domain. So make sure you have a solid product team. Make sure that you deeply understand the product that you're trying to build, and the specific problem that you're going to solve. Especially in healthcare, I think there's a whole amount of challenges there, right? Like not just for a given problem, the way the problem manifests in India is likely very different from the way it manifests in the US. There are so many very specific challenges to the Indian context, and specific challenges to other developed countries context as well. So your solution has to cater to these, or define it upfront if it does not cater, right? But understanding the limitations of your data and understanding the limitations of where you're applying your solution be very, very critical for success. So
thanks Deepthi. I think that's very important. This segues nicely into the question for Alpan. So this has come up multiple times. What is more critical, fundamentals or more practical skills, or a mix of both? And I think there are other skills which have also been alluded to. If you could comment a little more on that, what is important for the kind of work you do?
Yeah, I think I've already partially answered this question. I certainly think at the entry level, when you start your studies, I think focusing on fundamentals is very important. But eventually you do need to pick up multiple skills, most of which have already been mentioned, especially if you're in an applied setting. You need to make as Deepthi said, you need to make the product manager your best friend. And in order to do that, you have to be curious, you have to be open to learning new things. So I think that mindset, developing a mindset of curiosity outside your core technical area, but generally being curious about things, willing to pick up, learn things that are not necessarily technical in nature, but may reflect human constraints on the ground, right? That's very, very important. And specifically, I think in the work we do, you're not going to be successful, or you're not going to enjoy the work unless you have a certain level of empathy. We build AI for the bottom 95%. Right? We don't build AI for the type of people who are in this conference. So you have to have a certain level of empathy. You have to be able to go on, undergo the rigors of field trips. We tend to send our technical people on field trips into rural areas where they interact with their customers, with the end beneficiaries of the models they are building. And you have to be able to enjoy that type of thing, and empathize, deeply empathize, and want to make a difference in the world. So I think all of these are soft qualities, but are very important for success. And I'll just stop there.
Thank you, Alpan. I think that's a really important message. Again, to the attendees, we'll just extend this session by 10 minutes, and the networking session will start soon as the Q&As have been addressed. So I'll start asking some of the questions we're getting from the attendees. Any of the panelists, you're welcome to take the question. So one question is, with the increasing emphasis on kind of practical aspects of data science, how will education change in the future? Are advanced degrees going to be as relevant as they are now? Are degrees like the masters and PhDs, are they going to become more valued or less valued? if anyone wants to take this up.
Maybe I can start.
Sure, please.
Yeah, I think unfortunately they will become less valued. And I say unfortunately because I think there's a greater emphasis on skills than understanding that's happening, I think, across the board. So I do think, you know, short courses are a very good format for teaching you skills. And so you will see the world moving towards a much more sort of continuous education environment where you're learning skills as you go along, right? And I think I think even hiring will be, I mean, I could be wrong, but this is, I think even hiring will be very skill based rather than based on where you got your education or what type of education you got. And I think that is partly unfortunate. I mean, partly, of course, it creates a level playing field. Anybody with skills, no matter where they, where they study, will have an equal chance. I think, but the other end, in primary education, I think there's a lot of positive things that can happen due to the advent of Gen AI. I think there's a huge opportunity for democratizing primary education because you can augment teacher skills through LLMs. You can make sure that students studying in a small village government school have the access to the same resources as students studying in expensive private schools. This is all possible with Gen AI and the combination of ASR and LLM technologies. So I think there's huge positive things to be said about the primary education space. I think in the sort of post-secondary and postgraduate education space, it's probably a mixed bag.
Okay. So I think the next question, maybe Dipyaman can take it because you mentioned about data. So this question is, how can we be careful when building synthetic data sets, especially when you don't have a sense of how close the synthetic data set is to reality, you don't have a good understanding of the physics of the system when you're building the data sets. So if you could comment on that. I think you're muted.
Sorry. Yes, of course. I think synthetic data sets can act both as a good thing and a bad thing, and you have to actually do rigorous testing to figure out that if it is working for you or not. So in many cases, what happens? The data is what we have is not enough, and we need to create synthetic data specifically in case of images. In case of right now, we are also seeing in case of languages also, since we now have the Gen AI and LLM, people are using that to augment their data sets. But you have to be careful with that, right? So you have to look at the bias that such Gen AI or such generative models can bring to your already existing data sets. So I think in the previous session, somebody mentioned concept drift. So one of the things that if you have worked with data models, machine learning models, you already know that after a few months, your machine model, ML model performance will go down. Whatever you do, it will go down, and you need to retrain your data. So if you are retraining your data with synthetic data sets, you have to ensure that you are not sort of going into that concept drift and in building something which is entirely in conflict with whatever data that you have, the real data that you actually have. So you have to be careful in that. There are techniques that are available to sort of prevent such problems and to make sure that your ML model does not go haywire. But you have to be overall, you have to be careful in vis-a-vis with your existing data. So your data that you have collected from the ground, that you have actually manually curated and you have prepared. So I would rather put a little more weightage on that rather than on the synthetic data part. But if you are really in a data in a problem where data is really scarce and you have no way other than to use synthetic data sets, I will probably go with a little more of weak supervision kind of technique where I will go iteratively trying to sort of impute or sort of add some synthetic data, try it out, and then iteratively go from there rather than doing everything at one shot. So that would be my approach to that.
Mm-hmm. Great, thank you. This next question, maybe Professor Subhashis can take it, because you mentioned about Bayesian learning. So the question is, what will be the next potential big architecture of transformers that might kind of revolutionize applied ML? Do you see kind of where are gaps where there could be kind of foundational changes?
Yes, no, that's a hard one to answer, right? Where will machine learning? I will interpret that as saying that where will most machine learning research need to concentrate on? Trying to figure out how the thing works, right? I mean, see, the Bayesian networks have their limitations, of course, and they're more explainable, and that is a fundamental limitation. And so, as we know now, just statistical principles are inadequate to build effective machine learning systems. There are other things that come in. There are embeddings. There are large-scale correlations, and so how do actually machine learning systems, large deep learning systems work? What is the underlying theory? Very little is understood at that stage. There are heuristic understanding. There is some theoretical understanding, like intersecting manifolds and stability of manifolds and so on and so forth. But none of them are complete in any reasonable way. So whether transformers are the thing, or how they'll modify and how they will go. So I think it'll have to be both empirical work, hit and trial, which is the way machine learning, deep learning systems have evolved to a large extent. And at some time, if we are capable, more theoretical work to explain the underlying model. I think both will be necessary.
Thank you. This question can, Deepthi, maybe you can take this. So what is the opportunity for the use of LLMs in the health sector?
Oh, that's a big one. So there are so many opportunities in healthcare sector, and I think we are still uncovering a lot of the areas. So I can start with a few. There's the opportunity to optimize the doctor's workflow, right? Especially in certain areas like where patients have long journeys, for instance, oncology, neurology, nephrology, all of these areas, the patients come with long journeys. So there's also a lot of data. So, between 3 months of an oncologist visit, there may be tons of data for that doctor to look through before the patient walks into the office. So, easily presenting that data to the clinician so that you can optimize his or her time in the clinic, as well as making sure critical data is not missed out as well. So that's one in terms of optimizing the clinician workflow in areas where there's a ton of data to be processed. There are also opportunities in opportunities in more back office work, right? Like for instance, there are treatment guidelines. Many in healthcare, many conditions are actually very well described in terms of like what to do in the case of a fracture, right? For post surgery, this is a surgical approach. Post surgery, what is a checklist, etc., etc. So there are very well documented guidelines. Similarly in oncology, as well as in a lot of areas. So how do you surface that information to the clinicians again optimally as well? Surface this as part of the treatment planning process for clinicians. There are clinical trials again where there are very painful processes in place today in terms of matching patients to clinical trials, and these are advanced patients, etc. So how do you match them to clinical trials? Again, understanding the full state of the patient, right, which is interpreting multiple modalities of data. There are images, pathology reports, there's longitudinal data in terms of let's say a certain metric that has been tracked over time. So language models can certainly help in almost all of this. And the whole idea of that you can actually map a patient's state to a variety of other bodies, right, such as treatment guidelines or even treatment adherence in terms of medicines, right? What has been the adherence of that patient to a certain treatment protocol, etc. So there's a lot of opportunity for LLMs in healthcare. In fact, there are chatbots, companion chatbots for the patient, for the nurse technician, to guide them in an intensive care setting. So there are a wide variety of applications that these LLMs can be used in. Like I was saying, the challenge is not in finding an application, right? But the challenge is making sure it integrates well with that with that user persona's workflow, right? There's no point developing a tool for a doctor if the doctor has to pull up yet another window while a patient is sitting there and look for treatment guidelines or anything like that. So the point is, how does this integrate with a doctor's workflow or a nurse technician's workflow, or even for a patient, etc. Right? So I think those are like the key challenges in healthcare. There are plenty of opportunities that will hopefully be, we'll make progress on those very soon in the next few years.
Thanks, Deepthi. I think let me just quickly acknowledge that the questions came from Amay Varhade, Gopinath Karmakar, Srirama Prabhu, and Rahul Kumar. And some other questions have been also posed, which I think the panelists have been answering. So thank you. I think in the interest of time, we'll stop here. Again, lot of gratitude to the panelists for taking time off on a Sunday and joining this panel and giving such kind of insightful responses. And thank you to the attendees for kind of sticking with us for an additional 10 minutes. So with that, I'll end here. Adwai, if you want to take over.
Yeah, sure. Thank you, Preethi. Thank you, all the panelists, Deepthi, Subhashis, Dipyaman, and Alpan. And thanks to all the participants. So we are at the end of the main part of this event. But as we know, there are certain another questions which could not answer in the interest of time, especially related to the panel. So I'd like to inform you that in these breakout sessions that are going to follow, there will be one more discussion room related to career opportunities in data sciences. So you can maybe raise some of those questions there, and we'll be there to answer you as well. There are other panels as well for related to applications of AI, multilingual and multimodal generative AI, and also about working with IKDD, how you can work with us, and so on. So with that, I think we can now move to the other link which has been posted in the chat by Raj. And so see you all there. And thank you to all the panelists.
Thank you.
Thank you. Thanks, everyone.
Thank you.
Thanks. Bye.
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 Indrajit, would you like to say one last word?
Sorry, I just muted myself. So thank you to everybody, and particularly the panelists, for taking time out on a Sunday. These are, I really hope there are lots of young people here who are listening to you, and they will have a lot to take away. So thank you for that. And also for the talks on emerging applications. I think we just tend to focus too much on what everyone else does, right? And if there's something that I can recommend to the younger people here, try to find out what you love and go for that, right? Rather than just following your peers. And this is something that has already been voiced by the panel. I think I just wanted to stress that. So with that, a big thank you to everybody, and that concludes our session today. We'll see you again in some future event. Thank you, everyone.
Thank you.